skip ahead. I'm gonna refresh chat here. Okay. Go time. Kind of. My hands are a little shaky today. I wonder what that's about. I'll have many lurkers today, yeah, because of Valheim. As much as I want to check out the Hearth and Home update as well, I don't know. Still have my and my friend's save file. So, if we do end up playing it, it'll have to be me hosting for once. Yeah, metronomic jams, right? All right, let's get the charger out of the way. At least they get to, like, I mean, if things work out properly today, I can finish the RC car, at least leave it in a position where it works, and then, yeah, and then work on Burn the Subs 2.0 with impunity. I want to get this one sort of out of the way. That means I'll have a little RC car I can race around too. That'll be nice. Oh, but I don't have those connectors. I don't know what happened to, like, yeah, they're on back order. I don't know how long they're gonna be on back order for. Maybe I can find them somewhere. Just start with a basic search. That is absolutely not what I'm looking for. That is what I'm looking for. $7? For 100? Holy shit. I mean, this is basically what I need, I think. In stock, in stock, in stock. I don't see a stock indicator. I don't know. I'm not going to spend $7 for that. There's a couple things that I want to do with BTS 2.5 version. I didn't end up going out and looking for wood. I will do that probably in the weekend. Looking for wood. We got a lot of other tasks to do ahead of that too. But it would be nice to get the old board down, get a new one up. Kyle Wheat, thank you for subbing. We're not doing anything with your name. Your name's just going to go into a list. It just goes into a list. Thank you for the 15 months. We will put you in the list of names between streams or between boards, and then those are going to be shuffled and put up onto the new board when that comes around. So thank you for subbing. 15 months. 15 months, little man. Put that shit in my hand. My phone just buzzed. It's buzzing me. Oh yeah, I haven't restarted this computer, so I don't have Discord up on it. Asking me questions like right when the stream starts that I can't respond to until it's over. No sense of showbiz. It's already a scramble subscript? No. That's not going to be hard to do. That's not going to be hard to do. I'll basically make that into a script that'll take names from a file and then put them into the database, into a new basically have to make a new database and then just shuffle names into it. I barely even need scripting for that. I can do it in Python. I'll just call in all the database structures, and we need to add a section to the database that also denotes whether or not something is a gift. Yeah, it almost doesn't need a Python script, but I'll do it in Python because it's just easier. It's easier to do in Python. thud, thud, thud. There's a little boom boom computer music-y. Let's go away from boom boom computer music. I've used all the other ones to death though. That's like an ancient one from last year. UFO. Rest in peace, burn the subs. Yeah, it'll be up again now. Looking forward to the new one. It's not gonna be super duper new, but all right, quit trying to drive for me. I know what I'm doing. That's more like it. Hufo, thank you for the 14 months. Appreciate that. Yeah, again, in between. Yeah. Sitting here telling them what tunes to play. In between the two boards, it's going to take the list of people who subbed, shuffle it, and then those are going to be the initial names that go up on the new burn the subs. So if they're gift subs, I'll note them down. I'm probably going to end up doing this by hand, just looking through the Streamlabs logs or something like that, and just doing it by hand just to figure out who announced their subs, and then develop a list for it. It's not that difficult to do, but I'll get around to it eventually. I could script something that would do that, or I could like run a partial version of Burn the Subs, but I'm not gonna do that. I'm just gonna let, because Burn the Subs like has to do its sequence of events, and we're gonna have to get into it to program it. So I could run something on another Raspberry Pi, but I think the laziest version of this is just gonna be me going through by hand and just cut and pasting everybody into a document, and then we can load them up with a simple loop in Python, shuffle them, and then punch them into the database using the database structures that we've got going in the Raspberry Pi already. And before a 100 gift sub bomb, oh Jesus Christ, that would be awful. It's an embarrassment of riches, but my name is Jesse and not Rich, so that's fine. Rich can be embarrassed. But yeah, that would be Data Boss. The Data Boss. Yeah, that would be a psychotic amount of work for me to do. Well, I'm happy to do it. Creator updates. What? This is new. Auto-host. Oh, that's right. People are bitching about auto-host being weird. One of Roboz's mods, Velkin, made a post about not liking the way hosting works now, and it became so controversial that he got like onto Reddit's like controversial front page apparently. Like it was actually a really popularly controversial post. Auto hosting is a way to support your fellow streamers, and you now have a new option for how they are displayed to viewers. To show viewers the most relevant channel for them based on their watch history, select display channels in an order personalized to each viewer as your auto host priority. I'm not gonna do that. I'd rather you just be on the landing pages. You guys know what you want to watch. Come on. That's so weird. Twitch and its little psychological manipulations. Looking for an easy way to adjust or mute individual audio sources on stream. Available for both Windows and Mac. Twitch Studios new hell no. New advanced audio mixers puts you fully in control of your stream audio. No expensive hardware or additional software needed. Ugh. 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 People need to pay more attention to their audio setups. I do too. I need to buy that mixer. That's like $600 though. That's gonna suck. That's really expensive. But then again, this is my bread and butter.
Just because it's
I gotta just pony up. Gotta just pony up.
the laptop's like over
You
here.
guys have paid for it already. Of
Reach
course, I gotta pony up for some wood too.
and then
I don't know how much Live Edge costs,
hit the mixer. So
but I want a lot of things. I know, right? I want streamer and music control for the viewer. What? I want a pony. Let's all get a pony. Actually, it would be kind of funny if I had just had a pony one day in here. I hear they're kind of jerks, though. Their ponies aren't very nice. You need any actual bread and butter? Kind of hard to eat plywood. What are you talking? What? Bread and butter is like dessert. You ever go through a phase where you could just eat like a whole loaf of bread, butter on it? It's delicious. All right, so we fixed the Windows switch. That was a good one. I gotta make sure that this thing stays somewhere that I'm gonna find it. I don't know where I'm gonna put that. I gotta somehow keep track of this thing for a week and not let it get lost in the mess that is this desk. I'll just put it over here. Put it on the other desk where it'll never be seen again. That thing was properly messed up. I'm glad that led to such an entire stream's worth of content. That was fairly interesting. box syringe. Hold on, it's two people talking at once now. You can buy blunt-tipped, like non-sterile syringe needles, and so you wouldn't. They would be safer to dispose. They just have a lure lock attachment on it. So if you have a lure lock syringe, which those are cheap to get, like 300 milliliter ones, those are the ones that I have. You can just swap those in, and then disposing them is so much safer. You can also get plastic, the ones that I use, the little plastic, the blue plastic ones. I bought them by like the hundreds, so. My arm is more universally warm. Oh, it's because this is in the frame. That's cold. Yeah, there we go. Now you can see the little detail. What's that? That sound. It's like a Windows 3.1 sound. What? That's like way louder than the rest of...
Also, I'm losing my voice a little bit.
We'll get through that part. All right, I'm gonna stop chopping up Metronomic. You guys should check out Metronomic Live. You get a chance. I don't know when he's gonna do a set next. He's probably coming up on one soon. Anyway, yeah, burn the subs. It's done. No names are gonna go up today. I will, however, go back through and note down all the names that have subbed between boards. It's gonna be a little while, and by a little while, I don't know. I want to say like a month, but who knows? We'll see how long it takes us, right? Because I'm not under any obligations to get Burn the Subs 2.5 up. We have our ideas. We got a list of ideas, and I'm going to stick to that. One thing that I'd like to add to that list is a way to automatically go through the border of the live edge that we're going to have. So what I'd like to do, and I think it'll be an interesting thing to do in Python, is to take a USB Xbox controller, plug it into the Raspberry Pi, and have that control the XY, and then have the laser come on at a brightness where it's not going to burn anything, and allow me to basically trace the edge of the live edge board. We'll make it into a game. I think that'll be kind of fun, but we got to code all that. That's going to be a little bit more of a comprehensive little project, and I'm of course doing my homework in the background. I know chat's going to try to do it for me. I don't want you to. I want to work on this stuff myself, and then I will bring you guys along the journey with me. But that's to come in the future, right? I would like to get another board up there. I didn't go out yesterday. I just wasn't up to it. I didn't want to get in the car. So I ended up hanging out around here yesterday, trying to just recuperate myself. I will, though, go out and try to find a live edge board. It's going to be kind of difficult because it's like 2 foot by 4.5 feet or something. I've got the dimensions written down in my notebook over there. But it's a weird size. It's a weird size, and finding a live edge board that will be that long, it might be a little difficult. But I'll do my due diligence. I'll look around and I'll see if I can find something that fits on there, even if it's significantly shorter. It should be pretty good, but again, I just need to go out and do it, and I didn't do that yesterday. So once we get a new board up there, I think everything will start to, everything will start to fall into place. There, that's what I meant to say. Everything will start to fall into place. We'll just work on these projects as they come up, and we can kind of organically transition into the new era of Burn the Subs. That's the plan anyway. Everything's gonna go sideways on it, though. That's how plans work. That's why plans exist, so that they can be ignored. Anyway, I still have these other projects that I want to get to. I still have the computer sitting right over there that I got to build. What's wrong with that? I need to figure out where to put the radiators, and then I'll need to spend a weekend transferring the parts in. There's going to be all kinds of issues with that, but I want to get that one done soon because that one's almost ready to go. And then the RC car was the other thing that we were working on. No, I never got a video card. It's just going to use the 970 that's already in it. I mean, it's basically just this whole computer just has to go in a new case. Unfortunately, the 1080 FTW I have the water block for didn't finish the right angle adapter, but the 1080 FDW is my current video card. That's what I'm using to play games. I won't be able to play Deep Rock Galactic without it. Oh my god. So yeah, I haven't done that transfer. I still also need to make a second mic pack. That's another project that we can get to. Maybe in the interstitial space between boards, but also I would like to design that current monitor with those cool little displays. That's another thing that I'm thinking that we might get into on Friday, because that's not a long. That won't take very long. I can do that very quickly. I'll have to see what parts I have on hand. Anyway, so yeah, that's sort of what we're up against lately, right? Today, I just want to work on the RC car. It's this little circuit didn't really work. We fired it up. Which is your favorite video game? No, I'm not. No, just no. All right. So today I want to work on the tiny little RC car. We put the circuit together kind of at a feverish pace last time we were working on it, and it didn't work. It just didn't work. It didn't work. It didn't work. What happened with it was nothing. Some of the LEDs didn't light up. You would accelerate. There were no steps of acceleration, and then it would suddenly just pop off and go full throttle. I think that might be the diodes being in a weird position, maybe. I don't know why the PWM coming from the microcontroller would do nothing to control the motor. We basically just need to do our due diligence on a printed circuit board. So this is step 2 of printing your own circuit board. Step 1 is to have a vetted design that you know works. Step 2 is probably to make the circuit board and send it out to be produced. Step 3 is to absolutely, under any circumstances, get it working in the form that it is sent to you. And then step 4 would be to do revisions and do it all again. So I need to actually make sure that this circuit works, and do the modifications to this circuit to make it work without, buying another circuit board. So yeah, let's do this. Let's figure out what's going on here. Hold on, I had a meatloaf sandwich for lunch. Meatloaf sandwiches are dangerous. Okay. Underpants. Now, we're not underpants gnoming this, no. Okay. So let's... Okay, there we go. I gotta make sure my voice is primed and ready for talking. This voice was made for talking. All right, so what are we doing with the RC car? What's up, Groovy? Basically, I want to make sure, well, let's repeat the circumstances. So I've charged the battery. This thing is now charged up. The thing about the way that this circuit works, I mean, with lithium-ion batteries, you don't want to over-discharge them. The way that this circuit works is that this radio module will stop functioning when you get below the lithium-ion voltage. So that's our safeguard against over discharging a battery. Over discharge. Our safeguard against over. Fuck, I can't. The words in my brain. You guys know what I mean. Anyway, that'll keep us from over discharging. And when it goes into that state, it's going to send a radio not connected PWM to the motor controller, which we have programmed to stop any motion, any motor motion, while it gets that specific PWM rate. It's like a special PWM signal that it sends. But it's unfortunately it is interpreted as just like a motor speed. So we had to make a special circumstance that if the PWM has exactly this timing, that means that is the no radio signal, and we have to treat it special. So as you're accelerating through, one of the speeds that you accelerate through is that special speed, but it'll only come up in like one cycle, so it's not noticeable in the speed of the RC car. Just a weird way to do it. I don't know why they did it that way. All right, so anyway, I think maybe part of what was happening with this thing, with the no throttle into full throttle, I think maybe what was going on is the programming, the EEPROM on that thing was set to have some weird numbers in it. I think we didn't calibrate it properly. That may be part of the problem. So let's let's investigate that really quick. What I'd like to do is change out the LEDs on this thing so that we don't have that white LED was really blasting our eyes into you know, oblivion. My retina have turned into ash since looking at that. So let's get all 3 of the LEDs out of this thing, and then I'll put, I don't know, maybe not all orange. Yeah, maybe I will. I'm gonna put all orange LEDs on this thing right now, just for testing purposes. And I think I probably got some of the LEDs in backwards. So let's get the sluttering. Also, I'm gonna move the fan because I'm starting to sweat. It's not even hot out. Why am I sweating? Also, who soldered this? That's disgusting. Huh. Guess I should probably clean up after myself, huh? We should get out the goof off and do a little number on that. All right, so what I need to do is I need to get rid of these LEDs. That white LED needs so much more of a resistor on it. Let's just make them all orange right now. All right, hold on, let me kick the fan over here. I don't even need the lights on burning the subs anymore. It's just there to light the background now. Man, I'm like a shell of my former self without burning the subs. All right, get to soldering here. Now, do I keep? I wonder if I should keep the big iron on. Yeah, I probably should. That'll help me move these parts a little faster. We'll just use the big giant tip. And then get the mouse out of the way. I've wanted to troubleshoot this thing for like 5 days now. I've been just itching. I've been, you know, people will say chomping at the bit. I keep hearing that phrase more often, but it's champing at the bit. But I've been champing at the bit, wanting to work on this thing. Okay. Am I to believe everybody's playing Valheim right now? Is that what's going on? Is that where everybody is? Probably the case. Maybe. Hearth and Home. I'm curious to see what's in it. I'm curious. What else did they update? Did they have those new biomes working? Come on. Okay, these are, I guess doing all 3 at once is probably a bad idea, but you're doing Power Washer Simulator? I've seen a lot of people. I was watching Takahata play that a little while ago. That seems like one of those games that's just like inherently satisfying. Oh yeah, see that LED is broken. That's a broken LED. I worked on that one too much and it detonated. Oh, this slime areas? Is that the ones with all the webs? All the spider web area? All right, that LED is dead. I mean, these LEDs aren't going to make it out alive. Oh, cool. So the webbed areas will have stuff in them now. Ah. All right, well, that one just like ran with it. There we go. I'm relying on the fact that these will hold on to heat for just a little bit. I probably don't want to have the same soldering iron tip for the whole thing, but let me clean up the pads with a little bit of solder wick, and then I can throw some new LEDs on this, and hopefully we'll be able to get a proper readout and proper current flow on my circuit. Having the LEDs in backwards might have encouraged some weird current flow to occur, causing strange behavior, maybe. I don't know. Probably not. I think the main thing that we were working with is that the thing calibrated weird, and that's what was causing the strange throttle. But it was like 5 hours of work, and I was ready to just like be done with it. I wanted it to just like work, and it didn't. So let's get some new LEDs in here. I'm gonna put on the real pointy tip of this thing, the real pointy one. Ah, careful, careful. All right, so I'm gonna put orange LEDs on this thing, just so I know that it'll work. Although the orange ones don't have, they're not clouded, the lenses, so I don't know about that. UV is out of the question. We're not putting ultraviolet on there. Though I have them. I now have a bunch of UV LEDs, just in case I want to use them. White. We're not doing white. White hurts. It's so bright. Orang. All right, let's use orange. Now, orange has, I believe, the T on it, the little T symbol. Let me get 3 of them onto the board here. 1, a 2, a 3. Okay, 3 on the board. On the circuit board. Not on Burn the Subs, because Burn the Subs is dead. No, anyway. We'll get to Python programming for that. That'll be fun. I'm curious to see how, I mean, the joystick, I think, in Python 3 is easy to do. I think it's just like I have like a little GitHub thing that explains how to do it. I need to read up on that, but I think all we need to do is just like import it. Is this even a Twitch channel without BTS? It was. There was a time before BTS. Okay, so the little T symbol on LEDs. We just need to do SMD LED markings. Now we could do this with the multimeter. The multimeter could tell us which way is which, or we could just look at which one's the anode and cathode on a picture on the internet. So here's all the different symbols. Yeah. Oh, there is a dot. Everybody tells me they see a dot on it, and I never see it. Was the tank knife before or after? I think it was before. No, maybe, no, that was after. That had to be, I don't remember. I don't remember. So the top of the T faces the anode, which is positive. A plus, C minus. All right, so the positive side of the LED in this circuit is down here. This is the positive side of the LED because it goes back to the microcontroller. I've wired them in reverse. Basically, the microcontroller goes to the LED and to the controller that it controls, and then it goes through the resistor to ground. Subscribe to stab me with the tank. No. That was technically a violation of TOS. Even though I was keenly aware that the tank did not have the inertia to even break skin with that knife. Those treads are so slippery on the desk surface, and it would over accelerate. That's part of the movie magic. That's part of how they make the sausage around here, and I probably shouldn't tell you guys about that stuff, so that I can be a little bit more notorious. That exploding capacitor was the exploding capacitor was between boards, right? Or maybe that was before the board. That partially viral video where I had we had the stepper motor controller up at, I think it was like 50 volts, and the capacitor, or no, it was 30 volts, and the capacitor was a 16 volt capacitor. So you could see it on the thermal imager get really hot and then pop. That was a fun one. And then everybody in the Reddit comments was like, "Oh, is it your first time exploding a capacitor? Welcome to electronics." And I'm like, dude, like, all right, as long as they give me clicks, they can be oh, no, get off of it. Ooh, man. Trying to get these things in here, and the tweezers are a little bit sticky today. That's a little bit out of focus, isn't it? Focus. And then everything shakes because it's super sensitive today. It's all right. That's all right. That's all right. No, where did that? Oh man. All right, I gotta go find that. Let's do this first. I'll just grab the one out of this. The other one's probably on the desk surface somewhere. That thing really just flipped away, didn't it? If I actually was able to see the markings on these, the top side markings, I probably would have an easier time of this. Because apparently, theoretically, there's a little dot somewhere around there that I just can't see. Partially because I'm so far away from the screen. I guess you guys can put your faces up against the screen and really see it, but I'm a couple feet away from my monitor right now, which isn't the worst angle in the world, but it's not great. Okay, why are you... Could you just sit down on the pad, please? Thank you very much, TYVM. All right. Man, that one fought. That one was not having it. Let's find number 3. Is that it? No, I don't know what that is. Is that a hair? Oh, no, it's the lens from the other LED. You see what happens when you don't cooperate, huh? Yes, this could be you. All right, let's find that other LED. What happened to it? There it is. Well, you have a clean desk surface. So you can... Uh-oh. I was gonna say, so you can see where stuff goes, and then the tweezers went click, and, uh-oh. I don't see it anywhere. Is that it? That's it. There it is. Okay, it went all the way over here. I know, famous last words. It's like karma just basically interceded. All right, like that. There we go. Oh, no, that's not it. That's a different LED. That is a different LED. Probably the pink one. Yeah, I think it's pink or white. I don't know which one that is. That's not the right LED. Oh boy, we're back to this. I guess I can get another one from the tape and reel, but I would like to find the one that I was going to use. Nope, nope, nope. It might be gone. It might have gone so far that I'm not going to be able to find it. That's a possibility. There are 2 LEDs over here, but I think these are the ones that came from... What about this one? I think this is the damaged orange one. Oh, maybe it's not. Oh, this is it. Okay. Huh. My 2 LEDs were like on top of one another. Well, I hope that one's in good shape. Oh, fuck's sake. I did it again. This time I launched it over here. I need to solder this one down before it freaking runs away on me. Okay, so this one like that. Okay. Hold on. Please. Check. Okay. Oh yeah, positive needs to go down here. It needs to go in like this. All right, without unsettling it. Careful. The device is sitting on top of a connector, which is why it's wiggling like that. Let me move that connector out of the way. There we go. Okay. Jeez. I mean, I guess I can use the multimeter to check the continuity when I'm done soldering these down just to make sure. I don't really like how they're hanging out. All right, like that. And then I just need to add solder to the other ends of it. Why is this skating? This shouldn't be skating around. Why is it? It should have better grip than this. It's just like coasting around. Is there something under it? Weird. Usually it gets better grip. It found a particularly flat area and just like it was like an air hockey puck. It's not supposed to be like that. It's supposed to have that little bit of extra inertia from the weight of the vise. That'll give it a little bit of grip on the surface. All right, so there's no way that I can't add too much with this because the solder is so large, but it is adding it to the wrong part of the iron. But yeah, just like the littlest dollop will deposit too much solder. All right. I mean, I guess I could come back with hot air and clean this up a little bit, but I don't really want to. I don't have to do that. I think it needs a little flux, though. I think it actually does need a little flux. Everything's looking a little weird. Everything looks a little weird, so I'll just come in with the, oh, too much tacky flux. That is just way too much. I don't want, oh my God. Oh my dear God, that is way too much tacky flux. That's just what was on the tip of the syringe left over from last time. That is just a hideous amount of tacky flux. You know what? I might as well hit it with hot air. Because I have hot air. I have hot air. I might as well use it. Let's turn that on. Let's get that over here, and then I'll clean that up, and we can take a look at what it all looks like. I know I fluxed it all up. You got it. How's it going, Uncle Phil? Heat. Heat. Apply the heat. More heat. More heat. Yes, good. I'm doing okay. I'm kind of tired today. I'll get over it. I had a giant Red Bull a minute ago, so I'll be tweaky enough to be entertaining for a little while. Trying to get this RC car circuit board working. I didn't do any of my homework. I didn't go and buy wood. I know I should have, but ooh, wow. Did I just poke the entire, oh boy. I gotta watch the distance that I am from this so I don't ruin the LEDs. Oh, they're scooting around. There we go. Get the resistors too. Come on, resistors. How much heat is it gonna take? I guess I backed away way too far. Okay, let's get a little. I think with the larger, that means you also, yeah, I didn't get tacos. I don't, look at me, man. I don't need tacos. I don't need tacos. I need fewer tacos in my life, even though there weren't many to begin with. I don't know. Those look like they clean themselves up, but I don't know. Well, anyway, the LEDs have realigned themselves so they won't piss me off when they start, you know, lighting up. I didn't check to see if they were in the right direction, but next time I do a board like this, I'm definitely going to get a stencil with it so that we can do the whole oven thing. I was hoping, I mean, I don't have room for the oven on the desk. I'd have to bring it out here as a special thing. I was hoping that I would have the computer in the rack case by the next time I do a circuit board assembly, and that way I can show you guys what it's like with the, you know, the solder paste stuff. But we'll see where things get to with that. All right, so that was the first thing that I wanted to do. Before we check the status of the rest of the board, I wanted to make sure that those LEDs were oriented properly. Interference on the mic. Okay, one sec. I can see why my studio production-y friend really hates the mini XLRs. They're not great. XLR isn't that good anyway, too. Just a standard. But XLR is too big for my mic pack, so I use the miniature ones. All right, so in diode mode, in voltage mode, I can now probulate these things and make sure that they're in the right direction. Correct. Why did that start lighting up like, huh, weird. Incorrect. Although I am getting a voltage off of that one. Correct. What did I do here? I mean, this is giving me a volt. Oh no, it's saying OL. Okay, so did I do it backwards? This is my problem here. Still a bit of interference? Shit. What about now? Do I sound better now? This LED is dead. No? Ah, damn it. All right, hold on. All right, maybe that did it. Based on the green line? See, I don't see a green line on that. Sounds all right. All right, hopefully that persists. But yeah, it looks like this LED just doesn't work. It's just straight up not working. It's straight up having a bad time. It should light up when I do this. Or, well, actually backwards. There. Yeah, it ain't working. All right, let's get a new LED in the center position then. Center square, new LED. Let's go. I guess these LEDs are not as reliable as I thought they would be. Luckily, we don't have them directly connected to ground traces, so I can just get heat in there without it bleeding off very quickly. Of course, I'm using the very fine tipped iron, so I gotta be careful not to melt the LED next to it. I think I'm at enough of an angle that I won't. All right, buddy, come on. Out you go. It's just not cooperating. Hold on. You are full of flux and solder. Why are you not? All right, fine. You get more solder. That's what you get. It's this little iron tip is not putting in a lot of heat. You had every advantage. Squandered it. Oops. Well, that's going to make a little heat interface right there. Stop it. No, you bastard. Oh, I cannot believe you. All right. Please to be letting go. Please let go. Please. I don't want to spend all day soldering a single LED. Please. Please. Come on. Why is this not cooperating? It's like instantly cooling. Oh, Jesus. Well, there goes the lens. Some like resistors you can actually heat through the chip, and so you get both pads soldering when you're just trying to clean up one. This thing is just being a little asshole. Oh, there it goes. All right. Well, that was a disaster. Lordy. I blame the soldering iron. You know, a good craftsman when they blame their tools. All right, well, that LED is definitely not functioning anymore. We can pretty confidently say that at this point. Right, clean that up. Luckily, there's a lot of flux around, so everything is going kind of cleanly. All right, so let's get another orange LED in there. I need a new one. I put them all away. Here are the orange ones. Now, don't give up. When you feel like giving up, that's when you're liable to learn the most. You can really come back from, you know, the brink of total destruction with electronics. Some of the dodgiest repairs make for the best content, you know? So I want the tip of the T to go to the pad that I just put solder on to anchor it in. Okay. Looks like I damaged the LEDs a little bit. Maybe that's just flux. When I clean them up, hopefully those lenses look clear again. Okay, so I want it to go in this way. Okay, sticking to the tweezers is not fair, and it makes me upset. These are just 0805s. Like, these are like entry-level surface mount size. Are they 0805? Wait, maybe they're 12. No, they're not 1202s. Pretty sure they're 0805. That's my common resistor size anyway. Oh wow, the brightness on the camera is like really getting screwed with here. Oh, that's about to fall out. Please don't. Ugh, damn it, stupid thing. All right, back into the vise. Get a little bit better of a grip on that. All right, so let me get the other solder pad on, then we'll test them, then I'll clean up the area. I mean, that's going to be misaligned. I'm just going to live with it. I think there's still, yeah, there's plenty of solder on that. See, the solder is not cooperating with these particular LEDs. Really what I'm looking for is the solder to go up and over the edge of the chip. But it seems like these don't have a lot of material up and over. So I don't know what to do about that. I mean, that's soldered in, I guess. It doesn't look pretty. I guess it doesn't have to. It'll look pretty when it lights up. All right, let's do a little voltage testing here. So bring in the probes. Good. Good. The probe that I've got more space on here is the negative one. So testing them from other pads to make sure that it's conducting through my terrible soldering job. Bada bing, bada bang, bada bingus. All right, good. Okay, so those will work. I guess I can clean up the flux now, although testing it, you know, doesn't matter if it looks terrible, as long as we can do a good test on the components. But I guess let's just clean it up a little bit. What's the harm in doing that? And again, because apparently people haven't been listening to me, some of the things that I say on these streams, don't buy these, do not buy these. They are made out of 100% non-renewable material, and you blow through these things like they're nothing. It's so stupid. Get regular Q-tips. Regular Q-tips are made out of paper and cotton. Those are both renewable materials. You know, we're dealing with a lot of shitty chemicals here when we do stuff like this in very small amounts, but you know, any little bit, right? I hate how these are. They decided to reinvent the Q-tip and they made it plastic and foam. Like, what are you doing? What are you doing? It's dumb. I'd rather have those little cotton hairs all over everything than know that for the rest of the age of man on Earth, these things are going to exist probably inside of a dolphin or something. But ridiculous. All right, so what I'm doing is I'm just like scraping it like this. Yeah, just kind of rolling it around and scraping it and getting rid of that flux residue that causes this beautiful matte black circuit board to look glossy and disgusting. To make it pretty. Look at that. Oh, the lens is cleaned up nicely. So it was just flux on top of the lenses. I can't really get between them with this. Like with a Q-tip, I can just cut it with a pair of flush cutters, and I can make a little point that I can use to scrape in between things. These are dumb. I really don't like these. Bloop. That was way too much. Luckily, I think most of the electronics in here are solid state enough that they don't care if they get a little acetone on them. I know acetone eats away at plastic, but it does really well for cleaning circuit boards. Yeah, these were technically like designed for this. I mean, I bought them off of Amazon, and the packs were not expensive. But it's just like, it's so wasteful, you know? I feel like I need to be a little bit more responsible. What is in here? Oh, I'm looking at double-sided tape on the other side. That's double-sided tape that's holding down one of the modules. All right, so I mean that's a real gross job on the LEDs there. I'm not proud of that, but they're there, and we know they all work. So we can actually run this thing through the test procedure that we meant to last week. and we can actually get this thing hopefully running. I hope it's just a calibration issue, and maybe this whole thing works now. And then we'll assemble the RC car, and that's really what I'm hoping to do today. Not just show you guys how to troubleshoot a circuit board that's misbehaving. I can't believe, like, look, with modern CAD, it's really hard to screw up a circuit board that much. The one thing that I did is I put the two output channels of the radio module, I had them in the wrong order. So I had to do a little bit of wire shenanigans in order to get that up and running. That's it, though. Like, there's not too much that you can screw up because the CAD program does its darndest to keep all of your schematics and stuff correct. Keep all your schematics and stuff organized and correct, and check over your work. All the mistakes that I used to make designing circuit boards, and the multiple orders of circuit boards, and the fact that one of the primary steps is to get the thing in the mail and get it working, like scraping up traces and stuff, that is like becoming much less of a thing nowadays, just because of the organization that CAD lends to creating a printed circuit board. It's pretty amazing stuff. And we kind of quietly entered an age where batch processes, there are enough people who want to do small run circuit board designs, and the machines are automated enough to do big batches of circuit boards at once that it's become so cheap that you could just, I'm even a little reluctant to tell people that one of the steps of it is to absolutely, under all circumstances, get it working. Because it's like, oh, I messed one thing up. Here's $5 in 2 weeks. I've got new circuit boards now. Like, pretty crazy. All right, so anyway, let's hook this thing up the battery. I'll turn on the controller. Look at how shiny that is. I'm not used to that. I left the protecting thing on this for the longest time. All right, that's a little better. Now I feel better about just throwing this thing around the shop. This wasn't an expensive radio. I've seen modifications to this thing, by the way, where they add all kinds of different switches for all the other channels of it. So I was thinking, like, hey, maybe I could put some servo-controlled switches on this and have like lighting effects on the car. I'm not gonna do that. That's too much work. Yeah, sorry. I had to do that. All right, power on. And then make sure not to plug this thing in backwards because the diode isn't in there anymore. All right, so what's happening right now is it was getting partial throttle. So it's no movement until full throttle and no reverse. Okay, so let's calibrate the machine. So this is where I need to hold down the button and plug it in at the same time. But we have confirmation of all the LEDs working. And now that I've got all the LEDs in correctly, I just farted a bunch and you guys didn't hear it. I probably shouldn't have called it out immediately after. I don't have a switch on this. If I did this, okay. If I did this procedure, it would be much easier, but I need to plug it in and hold the button down. But now we've seen the LEDs work and we confirmed the problem that we're having, which is no partial throttle. It's registering partial throttle, but we're not getting any locomotion out of it. In fact, nothing is happening. Well, there's a little bit. Not really, until I reach full throttle. When we reach full throttle, this thing goes psycho. I don't know what's going on there. So I'm gonna make sure, I mean, this seems to be calibrated properly, right? Yeah, it seems to be calibrated properly, although I'm not getting any reverse throttle at all. Interesting. Why would that be? I mean, my weenie mode reverse could be set too low. And I guess I can check voltages in that case. I think that's where we are. It looks like it is calibrated properly because I am getting reverse and I am getting forward. So yeah, we don't need to calibrate it again. Let's do it just because. So I hold down the button and plug it in. And now it's indicating to me that I am testing, which one is that? Is that just neutral? I think it is neutral. And then I push the button. And then it programs it. And now it wants me to go forward, full forward. Push it. indicator, programmed, full reverse, push it, indicated, full reverse, and now I think radio off, push it, confirms it, and then it does a little 3 LED dance, and we're ready to go. Okay, why did you full throttle there, my friend? Okay, so everything seems to be in order, right? We've programmed all the presets on this thing, and the right LEDs are coming on. We're not getting the right behavior out of our RC car. It only goes full throttle. Why? Why would you do this? Oh man, this is not, I mean, we tested it on the perforated prototyping board. Not the perforated prototyping board. We tested it on the breadboard extensively, and we had partial throttle working. Now, it wasn't specifically with this motor, but we did plug this motor in, and we got partial throttle. So something's weird. And I don't know what the failure mode of these little transistor boosting chips is. Like, if I don't have a good connection on one of the pins of the transistor boosting chip, it's possible that what it does is just not respond properly. It doesn't use the PWM properly or something. I don't really know. Let's take a look. Let's figure out what's going on here. So over here are the 4 chips, the 4 capacitors associated with the 4 chips. Those look decently attached. This one almost looks like a cold weld right here, but I think that's just the trick of the lighting. Lighting can kind of fool you into thinking that you might have a bad connection, but it's definitely connected. It could use a little work, but that seems to be soldered in there. So the 4.7 ohm resistors are in there. Let's take a look at the other side and see what we get. Because what's happening basically is the forward and reverse are coming down and around, lighting up the LEDs, but then they also kind of sneak up. I forget where I had them sneak up, but they sneak up to the 4 little boosting modules at the top of the board. So here are little boosting modules, and one of the pins kind of concerns me. It looked like it might not have been soldered. They do actually look like they're fine though from here. It's possible that I could sneak that, maybe that transistor's not quite placed. Are they all in the same orientation? No. Okay. Plot thickens. Wait, no, yeah, they are. So what could the problem be? Or is there not a problem? Is it a problem with the throttle setting, just not able to move that motor appropriately? That would be a killer. That'd be very annoying to me. Let's get closer. We need to get much closer in order to see what's going on. Closer in we go. Oh, that's right. It doesn't do maximum close. Hold on. No blue smoke yet. We're still sitting pretty on that one. All right. So, what could the problem be? Oh, uh-oh. Well, first problem is this thing breaking off my my holder. There we go. All right, so I mean, connection to the motor is there. That's fine. They are all in the same orientation here. Does it look like, I mean, it doesn't really look like any of them could be shorting out. Hey, Baldizos. A mystery. Yeah, so no blue smoke yet. Nothing like that. We're good. We're good. There's not a lot of solder on these pins up here. Not a lot of solder on those pins, so perhaps those are the problem? Maybe I was the problem all along. What the fuck was that? Wait, hold on. The tablet behind me made a noise. It's not supposed to make noises. Why did you make a noise? You're supposed to just be sitting on power. What is this? Wait. Why did you just make a noise at me? Pump base space used what? The Hump Day space usage report is coming. What the fuck? What the new app updates available? I don't give a shit. Jeez, what the hell? That's weird. That tablet is an old 7-inch tablet that I used to use on the train going to work, and I mounted it on top of the DRO so that I could have chat over on that milling machine while I'm doing like a milling project, because the big monitor's right here, and I miss what you guys say when I'm doing milling. I haven't really used it lately, but yeah, it just suddenly like came to life and was like, hey man, I'm gonna do stuff now. And it's like, why? You've been quiet for like 6 weeks. Where's this coming from? Okay, so what is happening right now? Well, I don't know. We're only getting full throttle out of the thing, and it might be that this thing, if it's missing its capacitor, because this little thing right here is like a boosting circuit. Can I pull up the data sheet for those? I forget what they were called. I guess I'd have to open. Let's open the design in CAD first. Let's open the design in CAD so that fudge. Yes, that's what I wanted to search. Thank you. Wow. Thank you, Windows. I really appreciate that. Looking for the program to start, and it's like, hey, want some fudge? I'm like, no, I don't want fudge. What is wrong with you? Do I look like somebody who needs fudge right now? Particularly, what tipped you off? What assumption are you running under? Man, AI is going to be the death of us all just because it's so stupid. All right, anyway. Opening up the design. We're going to go to electronics. We're going to go down here. I'm going to open up the smaller board schematic files. I need to organize all of my project directories in Fusion, because what I'd like to do... Wow, look at all the space that we've got to work on stuff. Look at all that room. That's AI just wants you to think that it's dumb. I need to organize all of my project stuff so that I can host the Fusion 360 files on the Discord. I mean, I know how to share the links to stuff, but all the connections to like parts that I've made and stuff might not work. So I'm not sure how much I can share, or how much I need to share, or how that operates. I think it imports all the parts that are required for you when you put these things into Fusion. But yeah, anyway, we're working on this part right here, and it looks like there's not enough solder on these parts. The pins right here and on the side of it. Those pins are what connect this thing to the capacitor that it uses in order to create that little bump in voltage. Actually, that's the power pin. So maybe it's starving for power. Which are the capacitor pins then? Well, I guess it just goes between power and ground on the chip. Yeah. But yeah, let's open up that chip. Let's see what chip that is. That would be from the schematic. We got... See, these things, I mean, they could use a better symbol. Like, the transistors look great, but then these things are just like a big box. I made this part, so this is my fault. Mike 5019. Let's look that up. Let's look up that part. We had great luck with these. Blastisos. Hey, thank you for subbing, man. I'm happy to have earned it. Oh, here we go. I just searched Mike, and Mike 5019 came up on a microchip search. That's probably not the best way to get the data sheet. Yeah, it's not. Look at how long this page is taking to load. What are you doing? This is what I get for using modern parts. I just opened up DigiKey and I looked for this type of thing, and this looks like a fairly recent thing. I don't know what year these came from, but okay. Documentation. Download the data sheet. I don't want to download it. I want to open it. Oh, you bastard. All right, fine. Mike Rel. Sorry, it's not. Yeah, it's Mike Rel. Anyway, ultra small, high side N channel MOSFET driver with integrated charge pump. Now, to be honest, I probably could have found a 4 combo of this type of thing. I looked for an individual because I thought I might need to split up the gates on this circuit. I managed to actually make it work out where I didn't have to split up all the parts. So now I've got this like block of drivers and then this block of transistors, which is a little bit, I don't know. I was thinking like maybe I could move 2 of them to the bottom part of the board, but then I put the power input right underneath these pads. So that's Whatever. Anyway, these can handle 5 amps, and these little guys right here are built to switch those N-channel FETs, whether they're high side or low side, which is pretty cool. I really wanted the chip emotes. That's another one of the background projects that I need to do. Is I haven't even done animated emotes yet, and I'm capable of doing all that stuff myself. I've never hired an artist to do this kind of thing. I will get into my files one day and do the whole ADHD hyperfocus and like do pixel art for a day. I tried to do it on stream, but we got distracted by stuff. I made a suffer emote. I'm gonna update those emotes. I'm gonna get some new emotes in there. I know the tier 3s should all be money themed, and some of them just don't look good. So I need to get to those, and I apologize that I haven't done it yet. But I'll focus on that in the near future. I'll spend some time. Problem is, with the pandemic sort of settling down, everyone has come out of the woodwork, and so this weekend I got to work on cars with a friend of mine. My time is just like, as soon as I started stream, I got a text about it, right? And as soon as I stop stream, I'm gonna get other people who want to do stuff. And it's like, guys, I got kind of used to like living in a cave. I need to go back to that because I got a lot of work to do. I need to go on like a work vacation, just tell people I'm not around. All right, 2.7 to 9 volt supply, generates gate voltages 9.2 from a 3 point, blah, 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 blah. Okay, so that's all the complicated stuff. What this thing does is it has this 4.7 microfarad capacitor going into VDD, and then it bumps that voltage level up so that the MOSFET can switch. So in the case of one of them, that connection is not, it doesn't have a power connection. So I'm wondering if maybe that's what's happening with the in pin and the out pin. Maybe something weird is going on there. At least we don't have to invert our control signals anymore. Because before we had P-channel FETs on the thing, and those needed inversion, but when we tried out the circuit with the P and the N channels stored in the balls, it wasn't able to fully spool up the motor. So basically we're using it in these two configurations, which I find it kind of interesting that the high side says that it has to be 5 volts, and over here it says 2.7 to 9. That's a little, that worries me a little bit. I think it's okay though. We tested it and it worked, so I don't know why it wouldn't be good. I think maybe the problem we're having is just that there isn't enough solder on those 2 pins over here. But that wouldn't affect, right over here, that wouldn't affect reverse. We just get nothing for reverse. So it's possible also that these weird chips aren't making a connection. But yeah, let's try to fix that a little bit here. With hand soldering, I suppose. This board was really a good argument for buying stencils so that I could do the solder paste wipe. Look at that. I have this much material and that's the size of the pin. Are you kidding me? These things are microscopic. There's no way this doesn't deposit way too much. Oh God, it's so much solder. I think that, no, I don't think that deposited it. Oh God. If I can get the pad hot enough, I can maybe get just a little bit of this to melt onto it. Nope. All right, gonna have to do it like that. Ugh. Well, there's all that flux from it too. So this will absolutely bathe it in molten solder. I actually think that worked. I actually think that worked out. Yeah, it looks like that worked out. Okay. The power of flux compels you. Yeah, that went way better than expected, yeah. All right, now I'm gonna heat up this pad until that goes under and over, right? No, maybe not. Flux is basically voodoo magic. Not really. It just keeps it from oxidizing, you know? All right, so those pins look like they're moderately attached. Now, the thing is, I could come in here with hot air and try to solder all this stuff. But these are very prone to moving when hot air is involved. You can see that this one's a little bit crooked on the pads. Now that's okay because these have the connection to the solder pads all the way in the corners. So those corners are soldered right now. If things are just pushed out of the way a little bit, it'll be okay. I think that one's making all the connections it needs to. Just as long as we have enough solder there that it's able to actually, you know, connect. I keep saying connect in different ways. Those are all facing the right direction, and they all look soldered, which makes it kind of a mystery as to what was going on with this thing not being able to move the motor. Maybe it was just the extra drivetrain loss that was affecting it, but it really seemed like it wasn't able to do any partial throttle. Manfee0707, thank you for following. I don't know why we were only able to get full throttle or nothing. That's a little worrying to me. When did they trigger? I don't know. They were doing just fine with partial throttle with the other on the perforated prototyping board. So there's not much else for me to play with over here to fix. The rest of those pins look good, and they've all got their capacitors. Maybe they had different value capacitors on the other one. Oh God. Okay, look. Let me show you guys something. Because somebody was really, you reminded me that somebody was really adamant about this last stream, and it really pissed me off. NSIA 400. NSIA 400. This is like a, that was, oh, sorry, SIA 400. No. SIA 400 EDJ is the part, right? This is the N-channel MOSFET. And I got these from DigiKey. Here, let's just add datasheet. I got these from DigiKey, and now they're like impossible to find. They're on back order now. I have more of them coming, but they're on back order. These were like brand new, and they're pretty awesome. They're super duper tiny little quad flat or dual flat, no lead, I guess. No, they have their own package. It's like I don't know what they're, Power Pack SC70L. So technically, the drain has 4 pins, and so 1, 2, 6, and 5 are connected. They're connected. And so my pads for them look like this. They look like this. So if I go into the manufacturing tab and I do the preview on it. Actually, did I use that for the PCB? Yeah, I used the preview for the PCB. You can see that there is actually a bridge on the pad that I used. So that's supposed to be like that. My only concern, my big concern, is that under the part, no? Show hide didn't work? Okay. Well, anyway, under the part, that this is somehow going to bridge to its adjacent stuff. That's the concern, is if this is a little crooked, there's possibly potential for a bridge to form. They look like they're in place, though, for the most part, when we looked at them from the top. They look pretty well in place. They're not coming up off of the board, although that one looks a little suspect to me. But they are oriented moderately correctly. There's a potential that Q4 could be bridging. Q4 is pushed to the left a little bit, although that might be parallax. I tried to use all the arranging commands that the cat offered to make sure that those pads were straight. Well, I mean, we already had it powered up. I mean, we could go in and measure ohms on everything, but it seems like everything's functioning properly. I just hope we don't have like dead transistors, because I don't have a lot of these things. I don't have a lot of extras, chat. I should have ordered more of them when I ordered them originally, but I was ordering N and P channel FETs, and then it turns out it required a whole bunch of crazy stuff in order to get these things running. All right, actually, I need I need the car to be in such a way as to not have any connections from the wheels to the ground. What do I have as like a, here we go, here's a spacer, my chicken stick. Use my chicken stick as a, there you go. You ain't going nowhere now. Okay, plug it in. Observe the orientation of positive and negative. Plug the model in. Ooh, that little initial pull forward is concerning to me. I want to look at heat as I run through this. I don't know. Did I use them all up? I know I can extract them from other stuff. It still only does full throttle. What the butt? All right, so we're gonna have to get the O-scope involved. Let me try just connecting a different motor. This one doesn't do partial throttle very well. Hold on. I can get the perforated prototyping board active on this one. So this, and then where did that motor go? There it is. I got a perforated prototyping board ready motor right here. That was just for the testing phase. Let's get this a little closer. That and that. Partial throttle. Yeah, it's doing it to this motor too. You guys can't see anything moving there. I'm just observing. So this thing is only giving full throttle and no reverse. Partial throttle, nothing. What is happening here? All right. Well, what about the circuit board itself? Can we observe heat doing stuff that it's not supposed to do during all these shenanigans? I'm gonna go with yes on that one. The radio module is particularly warm. Let's see. So full throttle. Full throttle braking. Yeah, it's not braking. Double tap reverse. Okay, nothing is happening. Full brake, nothing. Full reverse. I mean, it's not full throttle reverse, right? I have a weenie mode reverse in effect. But like, anything less than full throttle, and you can see the throttle light coming on over here. Huh. Yeah, okay. All right. Why is it doing this? This is new behavior. This is brand new behavior from this thing. All right, so let's get the oscilloscope running on this, because we need to take a look at what the signals look like going to the stuff. I don't understand why that wouldn't be working. I mean, the only thing... that wouldn't make any sense, as if I got the transistors on here wrongly. Why is there like a... Why are these not visible anymore? What happened there? Wait a minute, what happened? Oh, those are just the boxes. I'm just going to Control Z my way out of that. I don't know what happened there. There. Jeez, that was weird. Must have clicked something that I shouldn't have. So yeah, anyway, yeah, I don't know where I went wrong. What could I have possibly done? All these are wired up correctly. I didn't get any warnings about missed connections from the software. They got their power in the right pin. They got their ground in the right pin. They got their diode, or sorry, their capacitor right there. And then the pins that are supposed to be associated with actually doing the stuff are associated with doing the stuff. There's no real drama here. There's no real drama here. They're all facing the same direction. Yep. Same pins doing the same stuff. In that one, out that one, in that one, out that one, up and around to the pin. Yeah, that's all there. Okay, I just had to do a quick little visual inspection of that to make sure. But there's no real... See, the problem is that I did this and then we actually built it and it worked, So why is everything going cattywampus? Why doesn't it work? Where's the circuit that we made? We made this. I took the board where we put the transistors, and we have two N channels. It's not pretty, but we have two N channels sitting here. And then I also made where's the other board? Or was it on the other side? Oh, yeah, there we go. We made these, which are those chips on a tiny little board. And those were able to be wired in with the transistors in order to get the motor to run at partial throttle and then at full throttle. You control multiple motors, or just one. You do two, you can check to see if both work like that. No, it's one motor. I mean, it's an RC car. So there's one motor that's under the controls of this H-bridge circuit, and it's got different modes. It's got forward throttle. So in forward throttle, one of the transistors will connect one pin to ground, and one of the transistors will connect one pin to power. And so that'll be forward battery voltage running through two parts of the H-bridge in order to, get the motor to run in one direction. Then you do the opposite. You have one and the other running in order to put power through the opposite pin and ground through the opposite pin. And you pulse one of those in order to do partial throttle. Under braking, you can power both transistors, two transistors that are connected through ground to the two pins, and that's like shorting them together, and that's a brake. That's all in there. That's all in the code. But it's all about controlling one singular motor. So let's check the signals going into these and see what's going on. I mean, we didn't get any weird heat coming from this thing. Usually when electronics are in that kind of failure mode, they're misconnected or something, we'll see heat going through the board because something is happening that shouldn't be happening. We don't have that option because nothing's heating up. We don't have that indicator of something is wrong. The only indicator that we have that something is wrong is that it's not doing partial throttle, which is a weird, like a lot of stuff has to occur correctly for it to have that kind of error. So we need to look at the signals now. We need to look at the ones and the zeros that are running around on the board trying to control stuff and figure out why it's in a situation where it doesn't operate properly. So yeah, that's where the O-scope comes in. Let's power this puppy up. We'll see what we get. I'm going to get one probe. I don't think I need multiple probes on this. My one probe is lashed together with the other one, so I should probably get these on two separate twist ties. Yeah, it's not multiple monitors. So if you're curious, my setup has two monitors on it, if you have to know. One monitor monitors chat, and the other one has it has chat, and then the other one has the project, my desktop window, just enough room for me to work, and my audio monitors on it. If you're curious. That wasn't the question, but start of my week. Work Thursday to Monday. Oh, damn, man. That's a long week. You get everybody on Friday, like, totally done thinking. All right, so we need a ground connection with this. The problem with that is that I can't get more stuff clipped to ground. So I happen to have this thing soldered to a little pin header. That means that I can just pop it right onto the breadboard. So now we've got the breadboard as sort of a hub for all the connections that we're going to make. So I can now put this on negative, and then I can put the battery. I'm going to need two more jumpers. I'll take these. I'll put the battery on jumper wires. We got the big battery here today because I don't want to deal with a cell running out in the middle of our testing. We need the battery because my power supply is unable to provide the inrush current to power everything up at once. I don't know what it is. It's something about the way the power supply operates. It is a very cheap universal sort of adjustable power supply. I believe that a more expensive lab power supply would probably have been able to provide all of that current right away in the instant inrush that the FETs require. But unfortunately, this one is not up to task, so we will replace it with a battery. Work a 4-day week. That's nice. Yeah. Must be nice. You're like, yeah, it is. All right, so that, and then this, that gives us our power connection. Now our probe is a ground, and I can use a little pokey bit to take a look at what's going on. So if we want, we can take a look at the servo signal coming out of the radio. Where are we going to do that? We probably need to go to a different view here. Yeah, it's going to be hard for you guys to see the scope on this, huh? See if I can get you guys closer to the scope. I'll see a little bit over here. So, all right. So what we're going to look at is signal going into Q3. Nothing. Where's the controller? The controller's way over here. The signal going from the radio would be on pin this one? No, maybe pin this one. There it is. So you can see that little lump right there, that little wave. And as I throttle up, the wave gets very, 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 almost indistinguishably longer and shorter depending on throttle or brake. Steering is over here. I can go right and left with steering. You guys could barely see that signal changing. Actually, I don't see that signal changing. What's going on there? It should be steering. I should be seeing a changing signal. Huh. Well, hope I didn't fuck that up. Oh, no, that's channel 3. Right. Channel 1 is here. Yeah, there we go. That's steering. Okay. Channel 1 is also right here. Let's just check steering. Okay, so our radio is putting out all of the appropriate signals. Yeah, the 40-hour week was not designed for the way people live their lives today, you know? All right, so throttle up. That would be the power pin, rather. Wait, this is the power pin. I ain't seeing no power on it. Or is that? No, that's the signal pin. All right, so this is the signal pin. Double back. I don't see anything on the signal pin. Oh, maybe this thing's broken. All right, let's look right here. This would be the signal in. I have no reason to believe that these are non-functional. But I'm not seeing anything on this pin. What the deuce? Okay, so that's part of the problem. Take a look over here. And throttle in. Okay. Throttle in. Braking. I should see a signal when I'm braking. Huh. How about you? Braking. Throttle. Nothing. Braking. Braking. Okay. Throttle. That. Braking. Reverse. 1, 2. Okay. We got weird stuff going on. Oh, there's my reverse. So that's going into reverse properly. What about the output of this? Yep, there's those spikes that this thing is inducing. Those are definitely a higher voltage too. That's running properly in reverse. Throttle, nothing. Throttle, nothing. Okay. It's buddy over here. Throttle, everything. Partial throttle. It's not functioning under partial throttle. Look at that. So there's full throttle, and then if I partial, there's like a little spike. What about the signal going into it? It's not doing partial throttle now. Why aren't you doing partial throttle? What's going on? It only goes full throttle. Oh, wait, but one of them does switch only when, so I think the ones in front are the partial. So if we look at this one, we should see partial throttle wave. We don't. No, this one instantly activates. Oh, okay, so this is the one that instantly activates. This one would be under reverse. 1, 2. 1, 2. There we go. Under reverse that. Okay, so here's the deal. On the H bridge, 2 of the pins, like one of the N channel FETs, will just instantly activate, right? And that allows current to flow through all the way through the H bridge. So in the case of this thing, U3 and U2, U3 and U2 are these guys. Are they those? Wait a minute. That doesn't make any sense. Did I wire these up wrong? Well, in that case, I can change the code in order to fix this, but I used to have 2 hours total cycling daily with my previous job. It's kind of nice, to be honest, because that way I had a workout done. Yeah, actually, I feel tired. I feel less tired when I cycle to work than while using public transport. Yeah, there are like hormones and stuff that are released from exercise that will keep you more awake. It was actually kind of great when I was doing the bicycling thing more. I would, before driving back to Philadelphia from Virginia, it's a 2.5-hour drive, I would exercise for an hour and then get in the car and drive and just be like perfectly awake. That's why I can't exercise in the evenings though. But yeah, I'm barely getting back into biking. I'm gonna do more of it. So okay, here's what I'm wondering is when I rewired this, when I redid this part and I added these parts in, it's possible that I swapped the pins around a little bit, which is, I mean, that's fine. We're not using super special pins to control the MOSFETs. We're using pins 3, 2, 5, and 6, and those can all do PWM. Pin 7 is our input. So I can swap that around if I need to, and maybe that's what's going on. I mean, we got it to work, kind of, but we need to make sure that we are on the right parts of the bridge, because what we need is we need pin Q1 and Q2 to be our forward and reverse constant activation ones, and then Q3 and Q4 should be the ones that get a pulsed signal for partial throttle. That's probably what's going on, is we just probably swap them around, which means I'm gonna have to reprogram the Arduino, which is really severely annoying, but it's at least something that I can handle. Man, if I swap those around badly, I'm gonna be annoyed with myself. So let's verify that. So Q1 and Q2 should be the ones that get. Shouldn't the topside FETs be P-type? We have somebody who knows H-bridges here. That's what I thought too. And then I found these parts, which are Micrel Mic 5019s. These are little boosters that will pump the FET voltage up just a little bit above the supply. And that's apparently really important to get your FETs to properly trigger, right? They need to properly trigger, so you need to boost them a little bit to get a basic N-channel FET that doesn't have logic control on it, which I discovered that these trench FETs do not have logic control on them. They're really good. They're really good. They're really, really good parts. These things are awesome, but they don't have logic level control. So I needed to add something to it in order to get it to bump up that voltage a little bit. And when I looked at the datasheet for this, they're like, yeah, high side, low side, who gives a shit? We control motors too. And I'm like, look at that, motor drivers is listed right there. And then this is them going, hey, we don't give a fucking shit what you do. Pretty cool. So I was like, all right, cool. Let's just use N channels. That's easier. They're cheaper. They handle a little bit more current. So this can be a high side and a low side N channel FET. Weird, I know, but it works. Well, presumably it works. We're gonna get it to work. We got it to work on the breadboard. We got it to work on the breadboard. I think I did a pin swap. I think I swapped 2 of the pins. So I need to swap them now in software because that's my only option. I could scrape up the pins and swap them, but I'm not going to do that. We don't need to do a hardware change for this. Does anybody have any book recommendations to learn Arduino, Raspberry Pi, and coding? Boy, you know, I didn't learn that stuff from books. I learned the book Command is the book where I learned how to use like do basic circuits and logic and stuff like that, and like why electronics work the way they do. Digital electronics are a different animal, though. Digital electronics are a different animal. You have ones and zeros running around on the board. You don't really need to know a lot of that analog stuff. It's good to have that foundation of knowledge. I don't have a book recommendation for learning Arduino, but
No, the art of electronics does not teach you Arduino and Raspberry Pi. You can, I mean, you can Google tutorials on how to do stuff with that. The way that I really got, like, cut my teeth with the Arduino and the Raspberry Pi is having a project. Having a project and then looking up the principles of how you do that project really helps kind of focus what you're learning and what you're educating yourself on. Almost an Engineer, thank you for the gift sub to Mystery 836. Appreciate that. We're not doing anything with the names right now. I'll compile a list of giftees and subs that'll go into the next iteration of the board. Right now the board doesn't work because it's full. There's no more space on it. And so we're going to start building a new board soon. I want to get this project out of the way. Heading down the mechanical route. Yeah, so, I mean, have a project in mind. Break the project down into baby steps. Perform those baby steps while Googling, basically, tutorials. And you will find that your basis of knowledge about how to use these tools will grow. There are I mean, if you're even struggling to do that, look up, there are plenty, like SparkFun has tutorials. All kinds of different websites have tutorials on how to start out with this stuff. You know, get your Hello World running, how to connect things, and they communicate it to the absolute very beginner. I'm not good at that because, you know, I did that a long time ago, so learning how to do this stuff. So yeah, might just teach myself a bit because any of the two give good basic knowledge to do anything you want. Yeah, I mean, there are applications that where I would use a Raspberry Pi over an Arduino, but the Raspberry Pi is like too capable. It's like a whole computer, you know? It's really good if you want to learn programming in like Python. Python's very accessible, it's easy to learn. It'll teach you some bad habits, but those are easily unlearned. And the Raspberry Pi, in regards to physical computing with Python 3 code, wow, that's easy. It's actually really fun to do. I was doing that with Burn the Subs. We'll get back to that eventually. But yeah. All right, so those are FET drivers. These are our FETs. I think we might have a problem with the connections. I might have swapped 2 of the pins when I was redoing the design, and I think that had a cascade effect on the performance of what this thing is doing. It's good that we're not accidentally shorting things out, but I need to check on things. So I need to make sure. Let's check Q1, because we should have Q1 and Q4 should be the active ones, right? And when we go forward, it's either Q1 and Q4 or Q2 and Q3, but Q1, Q4, we can check on. I can even look up my code and figure out exactly which one is which. But anyway, Q1 and Q4, let's assume that those are forward throttle, and let's test forward throttle. Because it seems like what I'm actually observing from these is to the contrary. So Q1 and Q4. Q1 is right here. Q4 is right here. So Q4 should be seeing a pulse width modulated signal on this pin from the microcontroller, and it's not. This one should be seeing just a constant. So where is that pulse width modulated signal going? It's not going there. And it's not also going, what the fuck? All right, so we're missing a signal output, unless this thing is like grounding it or something. How is it that we are missing? All right, I'm gonna flip the board. Rotatomorate the board. Rotato bordo. How are we not getting a signal out of this thing? We should absolutely be seeing a pulse width modulated signal coming out of this. So what were we looking at? We were looking at Q4, right? Is it actually Q4 or was it a different one? Well, Q4, let's follow the wires on the schematic, and that goes to pin 6. So 1, 2, 3, 4, 5, and 6. That's this one right here. Okay, so it's not doing a PWM. Did something break in our timing stuff? Why would that not do a PWM? That goes to the lower. What about the P channel, which is stored in the balls? That's our input. That's pin 7. Power. Pin 5, nothing. Pin 4, probably also nothing. Pin 3, nothing. Pin 2, that's just our N channel activation, our high side activation. And then pin 1 is a chuckle shake. Thank you for following. Okay. No, they don't need separate crystals. All right, so why am I not seeing partial throttle out of this thing? That pin should be doing a PWM. That's the problem. It seems to be a software issue. All right, that's a little weird. I didn't really change anything. Out of the microcontroller, we should be seeing a pulse. Something messed up with the clock? I mean, something is, well, at least for flashing the LEDs, it seems to be okay. I don't think I fried it while soldering. I don't think that. I mean, we put ATTINY 85s through absolute hell. Arduino? You feeling okay? There we go. All right. Okay, so the best that I can come up with is that this thing is not programming correctly. I didn't do something that I should have done when I programmed it. That's all I can really think of. Maybe I didn't load code into it properly, because we are using, but we're using one of the timers. We're using timing registers, which are a little bit more complicated, but they allow you more direct control, and you can get very consistent results because the microcontroller is not doing anything else but, well, okay, the microcontroller can do other stuff while the timing register is functioning, which means we don't use like if this pin is high. Instead, we have an interrupt that triggers when that pin is high, and that way we can measure the pulses coming in with a lot of accuracy. We don't have like code for the thing to go through before it comes back and it registers that the pin mode or the pin's state has changed. It really helped all this stuff clean up nicely. So the question is, why didn't this thing work? Why am I not getting a PWM signal out of this? One of the things that we did to this is we changed the rate, the clock rate of one of the pins in order to get a faster motor signal out. Our other microcontroller can do that. It was able to do that perfectly. If I wanted to, I could probably transplant one of the that other microcontroller into this circuit and it would work. Here's our loop, by the way. This is my program loop.
Hey, Eric, look at me. Bitch.
That's all our microcontroller does in a loop. It's all interrupt based. So if there's an interrupt, do something. Otherwise, hang out, right? So when we output signals, we are going to, oh God, this program's a little complicated. When we output signals, where are we going? I don't think we need to get deep into the code. But I have a program that's just like forward and reverse. Somewhere I've got it. Fast, slow, ISR, timing vector. See, the ISRs are where we're doing all the magic. Pulse reverse, pulses forward. Forward with the pulse time. Yeah, this is the program that I'm looking for. Forward. I guess if I just highlight it, it'll show it to me as I scroll past. Just gonna scroll on by without saying howdy. Where is that part of the code? It should be highlighting it elsewhere. It's not. Dear God, I have no idea what where my code is. Control F for, oh God, not in caps. Pulses forward. Forward pulse time. Find the other one. There it is. Void forward. So we just do a little mapping to make sure everything's clean. And then we digital write it onto the pins. So analog write Q4 pin with the mapped speed, pin Q1, 1. They never say howdy back. They just scroll on by without saying howdy. Okay, so I don't know, code-wise, I mean, everything should be working just fine. It could be that I didn't configure it properly. We did, possibly I'm using the wrong Tiny 85 core. Clock source, 8 megahertz internal. These are dangerous. 8 megahertz internal. Maybe this is overwriting it or something. Yeah, maybe this is overwriting stuff that it shouldn't be. And that's why the PWM isn't working. All right. I think I'm gonna pull the chip. I'm gonna pull the chip and then we'll program another one because there's no pulse here. Something is wrong. Something's hinky. So I'll use hot air just to go easy on myself. And we can just pull the chip. Let's unhook the battery too. Get the probe out of the way. Space things out so that I can heat up that area of the board. Darn it. Okay. I think it was the wrong ATTINY 85 core. That's my best theory. So let's shove some flux at it, and then we can grab this one out of here, and we can reprogram it and see if we can get it to work. Hot air, go. Hot air goes burr. I think it's down to the ATTINY 85 core. This is my theory, is that it's down to the ATTINY 85 core that I'm using. It has some overrides for the clock, and I think maybe those are messing with my ability to output PWM at the frequency that I've specified. And it should be a special frequency, but I think maybe it's not handling those ISRs correctly. It's screwing them up. So I'm using hot air to desolder this. It's not really that necessary. If you got access to like chip quick, that helps too. But hot air lets you yeet this thing just right off of the board. Ta-da! Now I don't know where it went. I've lost the chip. I've abandoned my boy. There it is. All right, so I can remove the solder from these pins to get it to go into the programmer a little better. I may not need to do that. It would probably be helpful if I could just transplant this into the circuit, but... Open dyslexic font? Huh. Never really played with it. Chip? Oh, it's right there. Okay. All right, pin 1 to pin 1. So I guess I need to load this with the other programmer, the other core, and we'll see if that gets it to work. Hopefully all the pins are properly pushed down with this thing, because there is solder on these, so they could... No, it looks like it'll push them down properly, I think. There's a little solder on the pins, so it's not quite pushing properly. Hey, Coderushed! Coderushed, thank you for rating with a party of 5. We're working on the tiny RC car, and my best working theory right now is that I loaded the wrong ATTINY 85 core into this, and as such, it ended up messing with the clocks a little bit, and so my PWM output is not working properly under the settings that I have this thing on. It should be 8 megahertz, which allows it to work in the voltage range of the battery, but it should also be outputting PWM on the pins that are doing speed control for the motor. And we had a situation where there was just nothing, and then full throttle. So we went back to the actual circuit itself, and we traced it all the way back to the microcontroller, not outputting the right stuff. Now, there's a possibility that I have some of the pins swapped by accident. I guess we're working on the PWM theory first, the wrong core theory, and then I'll need to, if it doesn't work properly, but we get partial throttle and it doesn't work properly, then I can go in and investigate. We did see a PWM output for reverse though. Why would forward throttle then not do a PWM at all? Oh, that's a little deeper into the question marks, isn't it? Shit. Well, let's try loading the different core and see if that breaks it or not. We'll just run with this theory and see if it ends up being the issue or not. Oh yeah, before I do that, I need to unlock the chip so that we can program it. It's a little strange that PWM was coming out of some of the pins, though. Hacker BBK, make it follow. That was me saying I appreciate it, but I wasn't able to get it out properly. All right, so I'm hooking that up to the USB thing that we had here earlier. And we can read it. Or not. Yeah, it won't read. Uh-oh. Pin 1 is there. That should be pin 1. Looks like maybe the solder on the pins is keeping it from connecting properly. Yeah, that's not reading it properly. This should be able to read it under 12 volts. Oh, no, never mind. Pin 1 wasn't on pin 1. Whoopsie-daisy. Whoopsie-daisy. That might be a dead Arduino now. That'll have to go into the fucked ATTINY bins. All right. We're gonna forget that ever happened. We're never gonna talk about that. Nope, that one's not reading properly that way either. I think he's dead. Oh no, there we go. We got it to read. So that red light means that the chip is locked. Now I've unlocked pin 1, which means that we're going to be able to program it now. Why is that getting hot? Why is that getting so hot? Well, it's not perceptible, but the chip is definitely visible in thermal imaging. Weird. Okay, anyway, that's unlocked the chip, and now I can program it. Shove it into here. I just hope it's not something on the board itself that's causing that pin to not be able to do a PWM. But I don't know. It's just like that pin just didn't do it. It could be a pinout problem still. It might not be programming. I might have done everything correctly with programming, but I don't know. We'll explore this problem first. So plug it into the programmer. We'll go over here. And now instead of this one, we're going to go to ATTINY microcontrollers 25, 45, 85. Now all those programming registers should already be set, but I think just to make sure, I'm going to do burn bootloader. And what that's going to do is that's going to set up the fuse bits on the microcontroller so that it operates properly. I'm just going to do this just in case. So my port is the new port that was plugged in. My programmer, I haven't selected anything on this list. I don't know if I have to. Let's try burn bootloader. Error while burning. expected for 25. Whoops. Oh yeah, I gotta select 85 over here. Clock is internal 8, COM 9, internal 8, tiny 85. Abort the board loader. AVR dude's done. And now I can burn, or I can upload the software to it. And now we just wait. Uh-oh. Can't open config file. Error while reading system-wide configuration file. What? What? Percent of dynamic memory. Hey, you burnt the other stuff just fine. What's going on? Oh man. So maybe these cores don't work. Maybe I was using the right core. Tiny 85, 8 megahertz, 25, 85, 45. Ports COM 9. Everybody's plugged in and happy. And we set the fuse bits on it earlier, so I think all the pins are definitely connected. If I hit upload, that should upload the program. It should work, but it's not. Something is erroring out. 1.02 avrdo.conf is throwing errors. It's throwing hands. So it seems like maybe it wasn't the programming that was the problem. Perhaps it was my assignment of pins. In which case, I probably should have explored it while the thing was still soldered in. Because, yeah. You guys talking about fantasy and shit? Trilogy, what are you talking about? Oh man, I don't think I'll ever get around to those books. Okay, yeah, still have errors. What the hell? Stupid thing. All right, well, the other tiny core works. This one, ATTINY core. And then I go to ATTINY 885, but not micronucleus, not OptiBoot, just no bootloader, because we're not using the bootloader on it. We're just throwing code onto there. And those are my only options for that. So 25, 45, 85 with no bootloader. I mean, unless I've got another one in here somewhere. Got ATTINY core, ATTINY microcontrollers, Mega AVR. Yeah, none of these are the right thing. It's just these two, but this one is broken. And I got Digistump, but I'm not using those. ESP and Teensy. So yeah, okay, we're stuck with this one. 25, 45, 85, no bootloader. Chip is the tiny 85. Clock source, 8 megahertz internal. Definitely not external. So we're definitely using that one. Timer 1 clock, I don't even know what to do with. LTO, I have absolutely no idea. Millicent micros enabled. I don't know. I mean, I don't know if we're using them. I think we might be. Yeah, save EEPROM. I don't know what the baud level is. Oh yeah, brownout disabled, so we're not doing that. And then our port is the same, etc., etc. So if I hit upload on this, well, first of all, I need to burn, quote unquote, burn the bootloader, because that's going to set those fuse bits properly so that we can use this specific core. So there's that. And now, if I just upload this, it'll do what it did before. It'll upload the code. So we're going to have to pay attention to what pins are doing what in the setup. I don't have the breadboard set up anymore. So I'll have to solder this back in. We'll be right back where we started. I mean, if it does work, then maybe we just had some kind of a sunspot or a subatomic particle hit our 1 and 0 and flipped it. But I've never bricked a microcontroller with those damn fuses before. Yeah, they're really annoying. That's why I built the fuse programmer, so that this thing is now hard coded with one job, and that one job is to flip the fuse bits to allow me to use pin 1. That's all it does, and it does it perfectly. And now I don't have to use command line codes in order to set up the fuse bits. because that was complicated and it was kind of hard to bring chat with me on those adventures. So we put it all into a microcontroller that does it for me. All right, so plug this guy in here, plug this guy in here, and then I can read, and then lock. There we go. So it's now locked. We're right back where we started. How frustrating. All right, so in order to get this back in, I need to desolder the pins on the board so that they're flat. And then we can put this baby back in where it belongs. I'm gonna sneeze. Ah, God, okay, all right. Whew. Well, back in you go. That's a real mystery to me, why the pin isn't, I think I need a larger iron tip for this. Well, I think I can get by with this one. That's a real mystery to me as to why this chip isn't, oh, damn it, stupid torque. Why this chip isn't outputting PWM properly. Well, there really wasn't much to, you know, the operation of this thing. I don't know why. No. We'll get to the bottom of it, for sure. Oh, crap. I was right down on top of one of the lenses for the LEDs there. I need to make sure that my soldering iron isn't, I don't destroy this whole circuit as I go through it. I need a larger soldering iron. This thing, oh wait, no, this thing isn't on. Dumb. It tried to save me from myself. Desoldering with such a fine tip is not a great idea because I can damage this tip by putting too much force into it. I could just come in with hot air until the solder flows. Nah, I don't want to use hot air on everything. All right, nice and clean. Nice and clean and ready for a microcontroller. But where do we get one of those? Off camera, I baked this microcontroller ahead of time. All right, there's this thing. Still solder on all its pins, which is going to be really annoying for me. Oh yeah, look at that, perfect. All right, come on, sit down. I could probably take a second to make sure that these pins are all cleaned off, but I don't know if that's going to be entirely necessary. It might be. Might actually be kind of necessary for me to do. Well, I could just press them down like this. There's already enough solder on them. It's twice baked ATTINY 85. Used to be an STM fanboy, then COVID happens, and all of them are a backlog for 40 weeks. Jeez. Yeah, they make some good chips. I don't know. I don't do brand loyalties. It's hard not to do brand loyalty when you have to learn so much in order to like learn so much for a specific piece of hardware, because that kind of makes you locked in, like the, you know, Atmega and their whole Arduino landscape. But I try to stay away from that kind of stuff. Same thing with cars. I don't like to be loyal to a particular brand of cars. I just happen to have way too much access to BMWs and BMW knowledge. So that's what I end up having and using. All right, so back to square one. Everything is plugged in. Everybody online, looking good. All right, let's see here. So if I'm not going to hook up the motor. We're just going to look at the signal outputs. Actually, let's hook up the motor. Let's hook up the motor just for funsies. So I need to get this real close because the wires aren't long. Should have put longer wires on this thing. I didn't know we'd be doing this so much. I thought there would be like one big glaring error and then everything else would kind of work out. Oh yeah, and then power's over here. And then in case we need the probe, I've got that over here. Plug that back in. A little song in my voice. All right, plug it in. That little initial forward throttle is very annoying. I don't know how to solve that. And no partial throttle. Of course, reverse is a pulse, but it's not moving the motor at all. And that could be something else. That could be a bad pinout. All right, so we're right back to square one. Right back to square one after all that work. We need to figure out what we need to change in software, because I believe that it is going to be a software change that is going to solve this. That's not the right view. There we go. So yeah, the pinouts that we've got here. No, that wasn't progress. Okay, let's check the pinout with what we've got going on over here. So, pin 5. Actually, let's start with forward throttle. So in our case, when we looked up forward, Control F forward, pulses forward, 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 U&8T. We pass it into here, and then this is what we're doing. So Q1 and Q4 should be the ones that activate for forward throttle. Q1 and Q4. Q4 gets the mapped speed. Q1 and Q4. We go back up here. We look at our assignments. So according to, there we go, 1043, Q4 is on pin 1, but that's not the physical pin. That's just what the Arduino says. Q4 is pin 6, which is technically PB1, which is output 1, right? So pin 6 for Q4. Q4 is our high side driver. No, it's not. Q4 is our low side driver. So that should be the one that gets the pulse. Pulse out of pin 6. And we verified that. We looked at that. That's why I'm looking it up specifically. All right. So that one is, all right. So, damn it, I hit serial monitor. Go away. That error message is now going to permanently be up. Okay. Oh, God. Oh, God. I'm dragging and dropping. Okay. Pin 6. So 1, 2, 3, 4, 5, 6. That would be this one right here should be pulsing out as I throttle up. It's not. It just does a direct thing. Is there a pin that is pulsing? Oh, it doesn't look very well connected. So pin 2, which is Q1, which is also connected to the forward LED. So that one triggers immediately, right? As soon as I hit the throttle a little bit, that goes high. So as soon as I unthrottle, it goes low. You just see right there. So that one is operating correctly. That's the high side driver. The low side driver is not pulsing. Where are my pulses? Why is it doing that? Maybe this isn't a software issue. I think this is a programming issue. But then when I go in reverse, so reverse is Q3, which is pin 5. So pin 6, pin 5, reverse. Oh, that's braking. And then I double tap. Oh, no, that's just solid, isn't it? I thought I saw a pulse on this. Wait, no, that's still braking. All right, reverse, double tap. 1, 2. Oh, there it is. So yeah, there's reverse, and I am getting a varied signal in there. What the hell? Why isn't pin 6 outputting PWM? And it should also, pin 6 should also be outputting under braking. It should be giving me, oh, see, I'm not getting anything from it. If I just go in reverse right now, I should be seeing a pulse there. Advent reloaded. Thanks for the follow. What's going on with this? Why isn't... Okay, so the pins are properly set up, right? So we know the right pins are on the right signals. Everything there works. I didn't get anything wrong there. That's a big relief to me. However, it's not pulsing on that pin. Yeah, I already tested the code. It's not software. I think it has to do with the way I'm programming it, because that part changed. I don't know. Something I'm doing in programming is not allowing pin 6 to output PWM signals, and it could be something messing up the clocks, maybe. But then we had another pin that outputted a pulse as well. That outputs a pulse just fine. I didn't change the code. Should I put the other microcontroller in? I mean, like, my circuit doesn't change anything either. I don't understand. Like when it gets a full signal, it triggers. My circuit is perfectly fine. I mean, it's just like just doubled the layout, right? These two right here go back to here. PB0 and 1. Those are definitely PWM pins. Those can handle it through the PWM engine. Pins 5 and 6. And the culprit is pin 5. Tracing pin 5. See if there's anything hinky going on with the circuit itself. It's actually going to be easier to trace it if I just look at this. Okay, so let's see here. I don't know what manufacturing fault would not allow you to have a PWM signal on a pin. That's a little crazy. Let's unview all the packages. All right, pin 5 comes down over to here. Who designed this thing? That's such a weird thing to do. All right, comes down over here. Here, I can highlight the hoop. Come back up over here. We trace it down and over, and then it goes around everybody. It's the all the way on the outside, and comes up and around, and it just goes to this pin. It just goes to that pin. That was the one where we had kind of wonky soldering, right? We had wonky soldering right here. Yeah, it's not the, I guess it's not the PCB if the ATTIny, because like what kind of a circuit layout would not allow you to have a pulse out? There would definitely be a pulse visible on that pin. So why is it like that? Isn't that weird? I think it has to do with the way that we programmed it. Maybe a fuse bit isn't set properly or something. It's so strange, because like we get the forward LED comes on, right? Here. Forward LED comes on. God, that is some ugly soldering, by the way. There's not much I could do. It's all tiny surface mount. If I go in reverse, that does reverse. If I double tap, there we go. There's full reverse. And full reverse is a pulsed signal as well. Although we weren't seeing any movement on that, I need to tweak that number. That needs to be a higher number because it's not enough to overcome the drivetrain, unfortunately. I need to set that to be like the minimum drivetrain moving. Yeah, but I did the fuse bit setting stuff. I wonder if it's one of these other settings, like these guys. Wait, what am I doing with the PWM is being set on its own? Like any of these could be the suspect one. Everything else is fun. Okay, here's the part that bends. This is the part that bugs me. We're getting PWM out on the other pin. The other pin is outputting PWM just fine. This one is not. That's what's bugging me. What was the order of did I get the wrong order of operations maybe? No, neutral, forward, reverse, radio off. Yeah, I did all that. So it's not running into that. What the fuck? What's going on with this? Why is it so dumb? Should I like throw another ATTIny 85 in it? Maybe that pin's broken. Yeah, I guess we'll throw more ATTIny 85s at it. Let's throw another one at it and just see what happens. I don't know, maybe it's not the core that, I don't know, maybe one of those bits that I'm using is set improperly and it's overwriting the clock, but it would only be doing it for the one pin because the other pin functions just fine. I literally just did that. I literally just did that. All right, yeah, start over from the beginning. We'll put a new microcontroller in there and see what happens. If we get the same error, then I'll look at those settings, because maybe that's where something's going wrong. Death Bubba, thank you for following this weird stream. All right, yeah, let's try a different one then. Okay, get a new ATTINY from the bin. That's where this one's gonna go. But where do they come from? God, Nigel. Let's find where my ATTINYs are stashed. They're around here somewhere. Ooh, that thing came open. Well, there's my ATTINY 87s. Not as useful. I should organize these a little better. These are kind of randomly placed. FET, NFET, opto isolators. Nope, nope, nope. Max 308. Check this thing. LEDs, there they are. ATTINY. All right, let's grab one. Maybe this will do it. I don't know though. Dubious. Dubious. My confidence in this is not high. We'll see what it does though. Oh god, these need to be washed. All right, that one. This one looks like something's wrong with it. No, no, it looks okay. All right, pin 1. Note the direction of pin 1. Pin 1 goes up here. Okay, as if socket's fighting me a little bit. All right, got that thing in there. We can plug it into USB. If they love USB so much, why haven't they invented USB? All right, that's on there. That's ready to program. So the first thing that we do, go up to Tools, and we go Burn Bootloader, and that's going to set those fuse bits. There we go. And now I can just upload it. So we'll keep all these settings in there. I'm going to hit Upload, and then we got to swap the chip. Probably easier to do with hot air. It comes out more gently when I do hot air, right? It writes it, it reads it, bada bing, bada bang, bada boom. AVR is done. Now I can grab this and I can pluck it from here and I can put it into my fuse setting machine. It'd be nice to wrap all these up into one big machine, but oh well. Fuse setting machine, I can read the bit. Now I gotta wait for it to start up. Read the bit. It is not set. Set the bit. It is now set. Now I can't program it with the programmer anymore. If I set up the programmer with 12 volts, I probably, I could do that, but whatever. Whatever. Wish I still had my test set up, then I could see if this is a super duper problem or not. And I guess I could put an LED on it and just plug it into the perf board. Just power ground. Do I need to do that? No. I'm just gonna desolder and resolder. We'll have fun doing some soldering tasks today, at the very least. So yeah, you gotta go. You're not welcome here anymore. Actually, it's probably perfectly fine, but we'll just put it to the test. Oh god, there's stuff around the cable. Hold on. All the programming stuff is in the way of the massive umbilical tube that this thing requires. And I just don't want it to shove stuff off of the table as I'm working with it. Hey, thanks for the follows. Fans of soldering and also programming. Try to get that out of the way so you guys can actually see what's going on here. My visual asthma, right? I'm gonna make your eyes tingle. Wait, that's really bad. That's really bad. Oh, I'm getting tinglies from what I'm seeing on this visual asthma. And away you go. Like it was never there. All right, let's put that one aside. Special spot. And then I got to clean up the pins again. That thing actually spools up the fan in order to cool it off. I can't do anything about that noise. It's kind of annoying. It's annoying to me. It's annoying in a sound studio. All right, pins are clean. See, that comes out nicely. You don't need hot air in order to work with ATTINYs. With the surface mount ones, we weren't supposed to be doing soldering and resoldering with this thing. It should have worked out off of the bat. And it could be my bad. I could have a wrong setting in here. So we're confirming that. So it requires a little bit of solder working and reworking. My only big problem is that, well, okay, so you don't need hot air in order to rework these things. You can desolder the individual pins and bend them to get it out. That's a little destructive to the chip because those pins don't like to bend. They have one singular bend in them before they break. The other option that I would have, I could probably try to program it in place by actually, and I didn't do that with this design, but I could have run a 6-pin in-circuit programming header onto this board, and then I could have plugged it in and reprogrammed it. I didn't want to do that, so my other option would be to use a chip clip. They make clips that will clip onto surface mount parts like this and allow you to access all those pins, and then you can wire those up to a programmer. But in this case, I have a ZIF socket for the ATTINY 85, and so what I do is I just shove this thing into a programming board. But, I mean, if you're working with the chips like I do, having that programming header on your design is very, very useful. I've got other designs that have that. I just didn't have a lot of space on this to run all that. And so if you find yourself in a position where you have to desolder something like this and have it survive, ChipQuick really helps. I don't mean ChipQuick from Amazon. I mean ChipQuick directly from ChipQuick, because they have specific formulations, and the one on Amazon that's easy to find is not the desoldering stuff. It's actually just solder paste. So I have some ChipQuick solder paste that I accidentally ordered. You can get directly from, this thing is powered on right now. I should have probably powered it off before I did all that. That was unique. Wait, did I? Yeah, I locked the chip. Okay, yeah, okay. Just had to be sure. Pin 1 was showing up, maybe just because I was still soldering everything down. That could have been bad. We literally just extracted a live chip without powering anything off. That was way too much solder. Damn it. Need to get thinner solder next time. I order solder once every like 5 years, so this reel has been active for the entirety of my streaming career. It's starting to look a little thin. All right, new chip, who dis? Power it up, even though it was already powered up. Power it up. Okay, it's misinterpreting the position of the controller. Wait, why is the reverse light coming on when I go? Oh no, that's... Oh geez. All right, so let's calibrate this. the default settings that I put in are unacceptable apparently, or it's counting them really weird. So yeah, what we need to do, I need to power it down, and then I need to push into button, and then I need to power it up, and then release the button. And now it's telling me that it wants to calibrate neutral. So I say OK to that by pushing the button again. Boom. Programs it. Now it wants full reverse. Push it. Good. Wants full forward. I might have mixed up F and R. Push it. Good. Now it wants the radio off. Push it. And we're programmed. And so now we are back in normal mode. Forward, reverse, neither are working. I fucked up. I gave it the wrong numbers. I gave him the wrong numbers. Okay, that was, I mixed up the order. Oh god, oh god, oh god. All right, push in the button, programming mode, enter. This is neutral. Neutral, press. Yeah, I mixed up F and R labels. Oh man. So R is blinking, which means full forward throttle. Okay, now forward is blinking, which means full reverse throttle. Duh. Oop. Now neutral, this one's radio off. Oh, the radio was off the whole time. God damn it. All right, start over. Push it in. Power. Programming mode. Give me neutral. Good. Full forward. Good. Full reverse. Good. Yeah. Forward and reverse. That's true off. Good. Everybody's happy. We're programmed. And we're back in. Forward. Reverse. Double tap for reverse. Okay. Yeah, it's still not doing partials. I don't understand why. I think maybe one of those settings I need to change. I don't understand. First of all, I don't remember. I could go back to like a VOD and figure out what the settings were. Because yeah, that's just not doing, it's just not doing waves. Why? Whereas if I go to this pin and I go tap, tap, and then reverse, nope, tap, tap, reverse, there we get partial throttle, which should be a little higher because the motor's not moving right now. Okay, all right, so it's something, I think it's some of those fuse settings that I've got in there. What do we think it is, though? Which one do we think it is? I've got the other microcontroller that I can program, so we can just do a big swap-a-rooney on it. We just do that all with hot air all at once. Tools, board, 254585, no bootloader. Chip is ATTINY 85. Clock source, 8 megahertz internal. So far, so good. All those should be fine. Timer 1 clock. 6432 or CPU. I don't know what that means. Because when we get into this thing, we're actually using the ISR timing registers in order to do some of our counting and stuff, which seems to work. All that stuff works just fine. Where are we setting PWM stuff? Let's see, PWM. PWM. Init PWM. Init PWM down here. Down here, we're going TCCR 0B, and then we're setting that 1-bit value of CS, of clock select to 00. CS00, what is that doing? I don't want to get all the way into the data sheet for this, but we might need to. I think we do, actually. ATTINY 85 data sheet. This is, I'm just trying to see what the settings need to be in the programmer. And this is like the real complicated stuff. So this is timer 0. What are we setting again? We're setting CS00, CS00. Bit 0, CS00, page 79. This is a long data sheet, man. CS00, that's the one we're setting. For TCCR0B. So output compare A, output compare B. CS00, we're only setting that one. So we're setting no pre-scaling on the clock. And that should give us a faster PWM. What's up, Star Vandal? Huh. Is it that we're not unsetting the other parts of the clock and maybe they're getting set by the weird clock settings that I've got going into this? If I set just the one, it's not going to unwrite the other ones, is it? Maybe that's part of the problem, is that the programmer is trying to set something with TCCR0B, and then we're just adding a 1 to the end of it. No, because we're ORing it. I don't know, man. I don't know bit math. What do I look like? I know bit math. Ones and zeros. Look at this crap. Look at all this crap. We are ORing it with whatever's already there. We're not ANDing it. So I think this is kosher. I think we're setting that properly. Everything else gets set to a 0 because of the OR operation. So why is it fucking up? Okay, so it is okay. So we're doing timer 0. That's where we're having problems. Timer 0. So what else would be screwing with timer 0 here? Well, that's timer 1. We don't care. And our timer 1 is being used to time pulses coming in, which appears to be working just fine. Yeah, math is for nerds. Let's just solder stuff together until it works. LTO. I don't even know what that is. We'll just disable it. I don't know what the fuck that thing is. And if we're changing one thing, I guess that's what we're going to try. We don't care about brownout. I think maybe LTO is the only thing that we could feasibly change in here. You know, the millis and micros being disabled, it doesn't really even matter. We could do that, but whatever. We're not running into memory issues. So, all right, we'll try that. I mean, I didn't change any code from what worked before. What could have changed is the Arduino settings, but like I'm super confused as to why like one pin isn't everything else functions on this. Everything else is functions, and yeah, it has no bootloader. It doesn't need a bootloader. We're flashing the entire core at once. That's just what settings we had. Totally unrelated. Still find it weird that the PIC microcontroller are behind some weird paywall for the compiler. Meanwhile, they keep the IDE and compiler for AVR SAM microcontrollers free. Yeah. I don't know. Let's just try this. Let's try it. Yeah, I've seen a lot of cool stuff on PIC microcontrollers, but I don't know. Why not just, you know, if the compiler and stuff is free, just go AVR, you know? It's just weird. It's weird. But there's a lot of stuff in industry that runs off of PICs. They're very good chips. All right, so I'm putting this thing into the programmer here. Let's come back here. We got to run it through the whole sequence. All this for a tiny little RC car, right? You guys should know that the struggle is kind of part of the adventure of this, right? The fact that I am now proficient enough to do base level timing instructions on an ATTINY 85 and other microcontrollers just through, oh, that wasn't where the thing goes, through Arduino. I've learned quite a bit more about how Arduinos and microcontrollers in general are functioning and how to use some cool stuff. You know, the real RC cars, the friends we made along the way. The only thing that I'm really pissed off about is the fact that these motors aren't properly spinning up. They're a little bit weak. I mean, they were supposed to be weak. We were supposed to get as much as we possibly could out of the motor. It does appear like this thing is going pretty fast. So, what's the top-down camera? The top-down camera that you're looking through right now is a Logitech Brio. You don't have to go out and get a Logitech Brio to have good visuals, though. Normal old Logitech webcams can do very good visuals. You just need to pull them through a sequence of settings, and then they forget your settings in between sessions. So what I do is I've got the Stream Deck plugged in, and I've got all those settings in there, so I hit one button, and it'll calibrate the camera. Oh, the top, this one here, this one is also a Logitech camera. This one is a, use the scope command to see exactly what it is, but it's a Logitech C920 that's in a special aluminum enclosure, and then it's connected to a C-mount lens adapter to a Nikon. And that's what we're using as the microscope. And that gives me a nice, like, 1 foot plus standoff on things. So I have room for tools and work. But anyway, the main camera is a Logitech Brio that's on a microphone arm. Okay. Program. Unlock so that I can program. God, this is annoying. What a weird problem, right? What a weird problem. I have one pin on this thing that refuses to work properly. Everything else works perfectly. Everything else works exactly the way that I had intended for it to work. Although those PWM signals might be a little slow. I'm not sure about that. You know, it all could be related to how the timer's being initiated. But okay, what's going on there? There we go. Unlock. What the? Maybe all the pins aren't connecting properly. There we go. I have to put, because of the solder on the pins, I might have to put a little pressure down on this thing in order to get it to connect properly. So there's that one. Now I can actually program it with our new setting. This is really annoying to do. I did not expect to have to do this. You know, it's at some point you got to think, like, where is it going to be easier for me to just put it onto the prototyping board for now and test it until I get it to work. I feel like that time is now. I feel like maybe we should just transfer this over to here. Well, that means I need to repair my little radio module. No, whatever. All right. And now I can go over to the programmer, upload with our new setting, which is none of that weird, that one setting that I think we can change. My thumb is shaking a little bit. Uh-oh. Please get through the whole sequence. I'm frustrated at PIC because I bought the programmer. Those can be expensive. Bought some microcontrollers, then found out about this other paywall on top of it. Yeah. Yeah, that's really annoying. Now, I mean, what I should have done is have test pads that I could access. If I was able to access test pads, then I would have been able to throw code at this thing all day, right? I said this some time ago. When doing setup on timers, always initialize the timer registers with the default value, then do modifications. Yeah, that's probably a good thing to do. But I think my command there does unset the other bits, so. Oh wait, no, that's the wrong thing. Oh, that's the wrong board, wrong PCB. I need to put it into this one. I need to set the lock bit. The problem is that I wouldn't have been able to set the lock bit. I would have needed the thing with the 12-volt supply on it, and then I'd be putting 12 volts into that poor LED. So that might have been a little barbaric. I guess the LED probably would have taken it, right? That command only sets, it doesn't unset? Ah, so if we have further issue, then that might be at fault. The OR shouldn't unset any bits. Yeah, maybe that's the problem then. We got fuse bit issues. Let's try this, and then we'll alter that command. All right, my assumption about how the bit math works was wrong. It was one or the other. Okay, so hot air. We're gonna use hot air. Get this thing out of here. And then I'll use hot air to just pluck the other one back down. Plop the other one back down. Plopping and plucking are two opposite operations, right? It's just a simple plop and pluck job. But then everything went wrong. I'll never forget the look on his face when the plan failed. Hot air, hot air, hot air. luck. Old out with the old, in with the new. Which way is this thing facing? Wrong way. Hold on. Gotta flip it around in my little staging area over here. And then we'll just plop it down. All right, let's get that back to soldering temperature. Shit, I'm shaking too much. Oh my god, fucking shaking. What is wrong with me? I was holding my hand up. That was the problem. I didn't have anything to prop down onto. There we go. There we are. Okay. Man, hot air makes a lot of stuff easy. Too easy, if you ask me. I'll let that cool for a second. Seems that old Atmel MCUs kind of do this stuff where timers get set and then left. So when in doubt, just set the whole register. Well, that's exactly what I was talking about. Come on. Just think you're so smart. Look at me, I'm in chat, I'm super smart. That is something that I mentioned, and we should circle back to that. Let's see what happened when I reprogrammed it without that one weirdo setting. But it seems like maybe, yeah, maybe. But actually, what I should have been doing, what I did was burn the bootloader, and that should have unset. I don't know if it messes with the timing registers. So yeah, maybe in the timing register, a 1 or a 0 was left in, and then my changing of the timing register didn't unset that. It's possible that I should have programmed the microcontroller like for an initial state. Whatever. Ever thought about making a UFO drone? Sure. Okay, turn the radio on. Turn the circuit on. Yeah, it still only does full throttle. Damn it! You stupid thing! Pin 6 right here. Full throttle or nothing. Why? Why is it full throttle or nothing? That is so weird. Double tap, reverse. There it is. Reverse has, I can at least change the amount of reverse that I'm putting into this thing up to where the limit is set. And I need to reset that limit a little higher. Defeats the purpose of calling it a UFO. That's true. It would be a very identifiable flying object. The definition of UFO, though, is it's weird. Everybody went all psycho about UFOs recently because of all that stuff that was getting released, and oh my god. It turns out it was a big wet towel, the release. There's nothing cool about it. Yeah, pics are like tanks, aren't they? Yep. Yeah, Yes Body Me says, I've had a PIC 18F something. Oh, I know those very well. PIC 18F something continuously running for 10 years in a garden decorating light. Yeah, man. Yeah, wet blanket, wet towel. I don't care. Shit. So it wasn't that setting. I'm making it stupid. Like, all right, all I can come up with is that we didn't initialize that pin properly. And maybe the Arduino thinks that it is a digital out. But I think we set it up properly. Pin mode. We set it as an output, so that can be analog or digital right. When we come down here, this is where we're setting TCCR 0B. So we need CS2 and 1 to be set to 0. So TCCR and underscore not bit value. Do we not it? Do we and it? Do we OR it? What do we do? Because I thought the OR equals would... Oh, man. Okay, all right. Bit stuff. Bit shit. Hate bits. I hate bits are so dumb. God, bits, you're so dumb. All right, so what we're going to do is we're going to set... actually, we can do that. How do we do multiples? It's somewhere in the code. Yeah, we do this. So TCCR0B is equal to BV CS0, this thing, and then we do ampersand. If that's the only value that needs to be modified to the register, just delete the OR. So if I just do it like this, it's going to set the other ones to 0. Oh, no, but we don't want... No, the timing register has other stuff in it that we don't want to touch. We don't want to touch the other stuff in TCCR0. TCCR0 has all kinds of shit in it. It's got all kinds of shit that we don't want to fuck with. If this were me coding this like 5 weeks ago, I would know off the top of my head everything that we were doing with timing register 0. I don't remember anything, so I'm not gonna touch whatever's in there already. So yeah, we'll do OR. We'll do OR. The knotted. I need an ampersand, and this keyboard sucks. I need an ampersand, and the keyboard doesn't have it. All right, now I'm just gonna steal one from here. Give me your ampersand. Ampersand BV of CS1 and BV of CS2. That's it. I don't listen. Okay, stop. I'm not gonna read in and verify every single little piece of code. Oh, WGM zeros. I've got blah 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 blah. Now we're just gonna make sure that this timing register is being set properly, because this is the one responsible for PWM. I just want to make sure that just those bits are there. I mean, these like. I'm not familiar with how this thing is working at the moment, so I'm not gonna push it. One or one is equal to 1. Oh yeah, all right. So maybe that doesn't work. How do we control them like that though? Because I don't want to. Yeah, we need to OR it with whatever's already there. Yeah, I don't want to unset anything. So that's going to retain whatever's already set. But then I need to force these to become those values. So I don't know if we OR it like that. Because what this is going to do is create a mask and then do those bit settings. Is that correct? Or do I need to like AND it? See, this zeroes everything out and then sets the individual bits. How do I make it blank out the stuff that I don't want? Oh, Lord. This clock stuff is weird. BV is bit value. So this is just a weird way of doing the bit math. It relies on definitions that are deep in the AVR code. Do you do anything else to TCCR0B before that? The answer is no, then it should be all zeros regardless. I don't know what this is doing in the background for it. Not OR is really used. It sets every bit. It is not to 1. I just want to zero those out. But I don't want to affect whatever's there already. So I have to do this operation. So if I do or equals that one, and I just do oops, that's the wrong one. Or equals and equals, just like I did down here, and equals not that value. So and equals not that value and not that out, or well, adding the knotted values to each other. Is that going to work, or do I and it? It needs to be, oh, it needs to be that. Okay. Yikes. Okay, so that's okay. Differentio. But we're not sure. Okay. Uncle Phil made sure to put asterisks around seeing what the and equals will unset values. So your supposition is that this will in fact make sure that these are set to not bit value, as in a 0. So these are unset, and this one is set, and those will overwrite only those locations in the register. So whatever's there before is still there. We don't know exactly what's going on. You guys have to understand, those of you that don't know, because we've got like 100 people here and we've got like 2 people talking. Those of you that don't know, what's happening right now is there's a specific type of timer register inside of the microcontroller, and this will do what is said in the data sheet as things are running in the background. So timer 0 is being set specifically to give us a faster output on the pulse width modulated pin. That's all happening in the background. That means that as my code runs, I'm able to give out a specifically timed PWM signal wherever it's called for, so that I can do my variable speed stuff without it being slowed down by what the code is reading. What you do now is or not, and not, and not. So the 2-line output, I don't remember what the calculation was for the fastness of the output, but it got us close to what the original microcontroller that we reverse engineered had, what the DOS Micro had. It was very close to their speed. The 2-line version was more correct. God damn it. Control Z. Bit math is very complicated because things behave a little differently than what you would expect. So what we're doing right now is we're using commands that get redefined in the programmer. TCCR0B is a memory location where a couple ones and zeros are stored. So instead of calling upon that memory location, deeper in the definitions files of the Arduino IDE are that memory location as it pertains to the specific microcontroller that we're using. These are microcontroller specific, so not all of them are going to have the same exact types of timing registers and stuff. This was a absolute, like, I only do this if I'm completely backed into a corner. This is cool though, but it means that if I decide to use like a different microcontroller for the motor controller, I would have to redefine a lot of this stuff, possibly. So the thing is, what we're doing is we're getting deep into the microcontroller. We're using weirdo defines. CCR0B is a memory location where there is a counter. Are you writing OCRA to set the PWM duty cycle? No, I'm using the Arduino analog out, which probably does that in the background. But yeah, so we're getting deep into the microcontroller. I remember writing code like this for the MSP 430. It's torture. It is kind of cool that we are taking over the direct features of the microcontroller and getting them to do our bidding. Basically, we did this, right? We did this. Everything worked. But what we didn't account for was that these registers might have had stuff in them before we started. So when I programmed this, I had already been tweaking with those registers. So there's a possibility that there were old ones and zeros in the register, and that somehow completely disabled pulse width modulation output on that pin, which is odd because reverse still works. Why did that one pin fail? Call the burn ward. Nope. Did you not read the title? Thank you for the sub, Corday99, 47 months. That's a 47-month streak. We're going to put your name into a list, and then it's going to get shuffled, and then it'll be burned onto the new board when the time comes. I'm so bad at coding, it should be illegal. Listen, look at me. I'm in a lecture hall full of 100 fucking shit-sucking assholes who can all type into chat if they want to. And I'm programming, and I'm not even good at it. To be 100% sure, I'd just do three lines. Oh God! All right, we'll eliminate the possibility that the bit math is dumb, because it probably is. It's so clunky to set zeros and ones, huh? Way better than me. I would have rage quit as soon as I opened the IDE. Man, it was a struggle to get to this level with this stuff. The extra ore is going to mess it up. BVCS1 or BVCS1 is what I think you want. Oh, so if I distributed that would have been better. Or just put it to 3 lines. Yeah, now it's good. I don't know if this is the fix, though. We don't know. I guess I'll just throw it in there and we'll do the hot air swap again. God, this is really annoying. I didn't expect to run into programming issues at this juncture. Yeah, the board is full. The board filled up last week. We had a memorial service and everything. But Burn the Subs 2 will start work on that soon. 2.5 rather. 2.5 is a slight update and upgrade, and that's it. Yeah, it actually, the IDE is probably going to truncate those instructions into a completely different form, so it's not like it directly runs that code. I need to desolder the pins on this. Hold on. Oops. There we go. This is the annoying part, is I hate that we have to work with these like this. Now, if I grabbed the ATTINY 85 off of the programming thing, you know, where we were working on it, then I could very easily just have this running. That's the kind of shit you see on YouTube, right? You just kind of pave over any of the problems. Oh, this worked perfectly the first time. We don't do that here. That's not how we run things here at Oh Bother. Those aren't fully desoldered. I think the ZIF socket will still grip them. If I had room for the programming pins, it would have been a good idea, but as a shit-sucking a-hole, I do enjoy the content. There you go. I try to keep it entertaining as we're working on some of the more boring parts of the hobby. But if we gloss over this stuff and get through it, we get to the cooler parts of the hobby, which is having a tiny little RC car. YouTube makes it look so easy, and people feel dumb for not being able to do it in one go. Exactly. And like, you know, even people in this chat are just giving, you know, they get to the heart of the problem very quickly, because, you know, you guys have an incredible amount of resources, and people all have a different experience point with the thing that we're doing. So even on stream, it is artificially easy for me to overcome a lot of these issues. When I was learning how to program in Python live on the air, that was like having a tutor that was really, really angry and had a bunch of different weird personalities. And I like Dewey and Schmide and all them, man, they set me straight on how to program Python. They really got got me to program well in Python for like 10 minutes. But I have the luxury of having a bunch of people who are tuned in and paying attention to what I'm doing. It's not something that you would do on your own, pursuing this hobby on your own. Pursuing the hobby on my own, I just was really adamant about learning how to make sure that stuff went right and looking up, I used to read data sheets for fun, and stuff like that, like just going through and just making sure and like sitting down with a pot of coffee and a laptop somewhere else that that you're going to be concentrating. Having that special place to concentrate really helps with the ADHD in terms of getting through problems. Oh, it also helps when you think that your classes are so boring that you want to think about this stuff while you're supposed to be learning. I didn't do too well in school. All right, so plug this thing into here. Read it. Oh, wait for it to come up. Read it. You son of a bitch. I can't believe you've done this. What's going on? Oh, I put it in backwards. Herp-a-derp-a-derp, I did it again. That's all I do, making sure that I know parts inside before implementing. The problem with microcontrollers is that you will never figure out precisely everything about the microcontroller before you start using it. Because those data sheets are daunting, and they're huge, and they're complicated. And I used to, oh yeah, let me do something with microcontrollers. They didn't give you a single piece of the knowledge that you needed in order to go in and start actually working with code. This was before the era of the Arduino. So you had the basic stamp, which I didn't really mess with. I think there were maybe a couple others, but that used BASIC, which is kind of sucky. I kind of hate that language. So you had the basic stamp out there, and that sort of started the ball rolling, but it was still a little bit too complicated. So you could get into AVR programming and PIC programming, but you had to pay a lot of money. The programs were like $300. And then you would get into programming the microcontroller, and everybody had a fucking stick so far up their asses. Like, AVR Dudes was like a hostile website where you could get some knowledge on how to work with microcontrollers, but all of it just sucked, right? I wasn't able to get anything done. I wasn't able to learn anything. I wasn't able to get to the meaty stuff of actually working with the code and having something happen in the physical world. So immediately upon exiting college, the Arduino was a thing. And I said, well, I got this accelerometer sitting here. I'm going to get an Arduino. Let's play around with it. Within an hour, I not only had the Hello World going on the Arduino and had it hooked up to a prototyping board, but I also had an accelerometer that was like a random part that I did for my that we tested for my college capstone project. I had an accelerometer on a board sensing so that if I tilted the board, whichever LED was facing more upwards would light up in a cluster of 4. That was an hour. That was an hour's worth of work on a perforated prototyping board. And I had something as complicated as an I2C accelerometer communicating with the Arduino. That is where, oh yeah, and total sunk cost of that setup was like $50 max. That price tag, that price point, the universal nature of the Arduino, the ease of throwing code into a microcontroller and seeing something on the outset, all of that combined is why the Arduino has such staying power and why it's so popular and why I love it personally as a platform. It gets a lot of heat from the hardcore microcontroller people because apparently they love this kind of stuff, which is having to build a bit setting program and having to do this and that and the other thing. But I didn't even get to this part initially. All of this stuff, all this complication that you guys are seeing here, this is at the end of a complicated project. It's not at the beginning. At the beginning of a complicated project, a very simple Arduino. Just using some parts that you have lying around. That's the cool part about it. We could potentially do an Arduino Basics tomorrow. We'll figure it out. Actually, Tuesdays should be the basic days. Yeah, so anyway, that when we talk about like PIC microcontrollers and when we get into the really complicated timing registers and stuff like that, like I don't like it. I don't like it. It's too complicated for what I'm trying to show people on stream. And you know, like what led me into this, it's easier for me because I have a bunch of people paying attention to what I'm doing. It's even harder when you go and set out to do it yourself. Start with the basics. Start with the basic stuff. And I don't mean a basic stamp. Nobody uses that anymore. I wonder what kind of projects that are still out there that use basic stamps. All right, so now we've got a couple more lines in here to very specifically make sure that my timing register isn't set to something stupid. I have a feeling that if the timing register wasn't exactly set, that could run into problems. That's why I think it might be a problem with the core that we're using. The core just not properly utilizing these things. I don't know why only that one pin would not allow PWM signals to come out of it, though. Because when I went in reverse, we had a PWM signal on that, too. Embed? I don't know that one. I have an ATTINY that I can throw into the breadboard, yeah. The perforated prototyping board that I can test it with. I mean, I probably might as well set that up at this point. I can just put an LED on pin 6. Sigh. Although, the problem is, if I switch over to the other ATTINY, we know that one works. We know this one works. If I reprogram this one, those registers might already be set. So I don't know. Oh, that's right. I vaguely remember it. Mbed is an ARM Cortex M0 that is a web-based IDE, C++ drivers and libraries. Yeah, I know. But, like, nobody's really using it, you know? I mean, I'm sure a lot of people use those, but the universal nature of the Arduino means that I can look up all kinds of different parts and stuff and code, and everyone and their dog has worked on it already. Same people that rant and rave 5 hours of what programming language do I use. Sure power there is under the hood if you just learn a bit more about it. The thing is, like, okay, so the important part is that the ease of use of the Arduino means that it's not just electrical engineers messing with these things. You don't need a degree to screw around with a microcontroller and make your Halloween costume have cool lighting in it. You don't need to do that. And you don't need to go to some guy who's produced like $100 board that you buy that flashes LEDs. You know, that's not necessary anymore. You can go out and you can get an Arduino without knowing a whole hell of a lot about electrical engineering, and you can find other people who have done the same from your same level of knowledge, follow the procedure of what they're telling you to do on, you know, a tutorial, and then you can put the LEDs into your costume, and then you have full control over how you sequence them and stuff. Instead of, you know, because it used to be, you used to look for somebody's board that did that job. Now you could just make that board, and you can find somebody's project where they make that board. So that's the cool part about it. That's what I really love about this, is it puts advanced, my examples are very simple, but it puts advanced tools into the hands of like artists so that they can do cooler art. That's what I love about the Arduino. Okay. We don't know what the effect of this thing is going to be, and we still need to do it with these microcontrollers, because if I swap this microcontroller for the one that we know works, it'll just work, and we won't have learned anything. So I guess we need to hot swap this. Well, not hot swap. I'll disconnect the battery, but we need to swap this thing in to the motor control circuit to get it working. This is such a weird problem, chat. You got to understand, this is such a weird problem. Like, we have one pin of this thing that's not outputting a PWM signal. Why? Why is it doing that? Why isn't that pin outputting a PWM signal? Is there something that disables that PWM output capability on that pin? I didn't change the code. Where's our forward? Control F, forward. I'm gonna look at it again just so I can be reassured. Forward, U&8T, rate. We're constraining it for the min and the max, given the rate. Min forward, max forward. We're remapping it from 0 to 255, which is what the input to PWM is. The map speed, if the map speed is greater than or equal to the max offset, then we're setting it to full. That's fine. That's just the very upper limit of the maximum speed. We're just making sure that we're capable of doing max speed. Analog write, pin Q4. This is why I think it's down to my selections here. I think it's down to my selections here. Because it seems like maybe that analog write is not being interpreted properly. Or something. I don't know what, though. What the hell, man? What is the deal? I mean, do I need to set... No, that's timer 1. We're not concerned with timer 1. We are timer 0. No bootloader. The other one is OptiBoot. Maybe we need OptiBoot. I pin multiplexers. What are you talking about? Like in the registers? Because I'm not touching that. I don't touch any of it. I'm not messing with it. All we're doing is writing a slightly different frequency for timer 0, and that gives us a different PWM rate out of this thing. It's more conducive towards motor control because there's less space between the pulses. I don't know. I don't see any reason why this thing would be. Break LED to low, Q1 and Q4. This could not be simpler, right? Yeah, pin 6 is the one that's not working. Pin 6 is associated with Q4, blah, 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 blah. Pin Q4, which is pin, I gotta scroll over to it. Pin 6, Q4. Q4 is set up as an output. It's weird that it goes high for just a little bit. Like the thing goes into forward motion for just a second when it starts up. Brake LED is the output. Pin Q4. Yeah, I don't really see anything that's wrong. Very, very strange. Oh yeah, this is how we set up a delay, by the way. I had to do all this to make a delay. And then I get my code stuck in the delay. Nah, we didn't get it working yet. Brake LED high, brake LED low, that's flashing. All right. Yeah, I had to program my own delay using timer 1. Timer 1 is very versatile, though. All right. Well, anyway, we set the bits a little differently to set up timer 0. And so in doing so... Yeah, this is the math, by the way. Or no, that's a different timer math. Anyway. Input in 0, interrupt from that pin, blah, 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 blah. Okay. All right, I'm going to solder this thing in. We programmed this all, right? I just did that? No, wait, we just programmed it. So I need to set the bit thing. Did I? Yeah, I uploaded it because I remember having to hold it and it kind of hurt. All right. So now let me set the pin 1. And then I'm just going to use hot air. I'm just going to pop the one out and pop the new one in again. We can't change the microcontrollers. I mean, I can plug this thing into the perforated board and test it that way. That would probably be a little easier, but this isn't all that difficult anyway. It's just plugging stuff in and using hot air periodically. That's going to practice me up on my hot air. It only becomes a delay for a brief amount of time. Actually, this code, which I believe I've uploaded to GitHub, this code does a very clever thing with the timers. It's like using all of the timers in specific ways in order to get all of its signal measurement tasks done. Yeah, make all your hot air jokes, guys. Let's get real deep into the kids' jokes book, into the 3rd grader joke book. says the guy who has a fart machine. Hot air. That is a visual gag that unfortunately will never get to the subject of the visual gag. That joke book, I thought it was clever. But that only came from one rant that he had. So. All right, let's get this thing into position. I gotta get my hand positioned so that I'm not shaking. Oh, that's a clever use of the hot air gun. Clever, clever. I'm positioning my thumb under the tweezers so that I can open them up and with minimal force, move them out of the way. Ooh, I gotta be careful that I don't overheat things. Yeah, see, that's pretty easy to do. I don't know about that one pin. Pin 6 may not be connected all that well. There's already flux on it. I'm not Rossmaning this thing. Yeah, he ranted that he'd ban other streamers from his chat because they would steal his jokes. And I'm sitting there like sweating. So, yeah. So that's where my visual gag came from. All right, let's test it. Let's see what happens. It's probably gonna do the same shit, right? All right, well, that's a little unique. What's going on there? Forward throttle. No partial throttle. Why are you doing this? Streamer's extra saucy today. Yeah, that's right. That sauce is free. I'm gonna give you more packets of it. Over here. Take a look. Put it on pin 6. It still doesn't do PWM out of pin 6. Why? 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 All right. Whereas this pin right here, if I get it into reverse, look at that. Look at that pulse. It's perfect. Why does pin 5 do PWM and pin 6 doesn't in this core? What are you doing? I wish there was a way. Oh, hold on. I wish there was a way I could tell what I did in the other programming and go back to the VODs and see what I was doing. I don't understand. Pin 6 is, what was it? PB1? Control F, PB1. PB1, MISO, D0, 0C, 0CA, PCN1. All right? PB1. Let's see what else you got to say about PB1. Port B. Data output. Analog comparator. Timer counter 0. Compare match B. We're not worried about that. USI data out. 3-wire mode. Oh, I didn't know it could do that. Pin change interrupt. I think PB1 does everything we need to. ATTINY 85. Pin out. Images. ATTINY 85 pin out. Pin 6 and 5 are the PWM pins, very specifically laid out right here. That's important because that's what we're using them for. If they didn't do PWM, we'd be in trouble. But they do. They do PWM. They do PWM. These little bastards. Lift pin 6 and check for a pulse. Yeah, that's a good idea. Maybe I'll do that. That was the clip. Could you find a clip of me programming the ATTINY 85 so I could see what my settings are? What is the difference? Pin 5 versus pin 6. One is pin 5 and the other one is pin 6. That's it. Yeah, it's 1. That's what the difference is. No? Okay, you don't have to. Don't worry about it. Yeah, I mean, so they're the same thing. They're the same thing. They're just a different, you know. The port B is all of the pins on this thing because it doesn't have a lot of pins. It's just a different position in port B. There are no specific registers to differentiate the two. There's only the input and output registers for those pins, right? Like if I set a PWM rate, that should be on pin 5 and 6. Let's Control F PWM. So let's see. There is a special PWM function, so we got to kind of look at that. Oh boy, there's just so much in here. T count. Ah, boy. Hold on, I got a hair in my glasses that's in my face. Ooh, get out of my face. Internal clock source. The clock source is selected by the clock select logic, which is controlled by the clock select bits. In the timer counter 0, control register. Control F, TCCR 0B. Counting sequence is determined by the settings of WGM 0 and 1. Located in the register, there are close connections between how the counter behaves and how waveforms are generated. Yes, yes, yes. WGM 0B register. WGM normal. PWM phase corrected. Fast PWM. Reserved fast PWM. So WGM. I don't think I'm doing anything with WGM. It might be that WGM is set in a particular way. That was part of the burn bootloader, was to set those registers properly. And it's possible that maybe this core that I'm trying to use handles those registers a little differently. I wonder if I set those registers with burn bootloader on the other core, and then I programmed it with this core, if that would solve that problem. I swear the people who write these guides have no clue how people get their info. You need pictures? Look, there was a picture and it was daunting. There was a big like state diagram of everything. Oh, I don't want to look at it again. I don't want to look at it again. All right, so what am I doing? I mean, I'm initializing my PWM and I didn't touch anything. I didn't set WGM. Now, can WGM interrupt the behavior of that one single pin and not the other one? I don't think so. I don't think so. We're not messing with it. I mean, I could just set it to 0, 0, 0. But that doesn't, like, none of this stuff affects one specific pin. A bit is only active when WGM bits specify a non-PWM mode. However, for string compatibility, this bit must be set to 0 when 0B is written when operating in PWM mode. When writing a logical 1 to the FCOA bit, an immediate compare match is forced in the waveform generation unit. OCOA output is changed according to its bit setting. Note that FCOA is implemented as a strobe, therefore it is the value present that determines the effect of a forced compare. Yeah, if this wasn't a searchable PDF, we'd be shit. We'd be up shit's creek. Force output compare B. So force output compare A and B. Those don't go to a specific pin, though, do they? Nixon Nelson, thank you for following. I didn't want to have to get into this stuff, but apparently we got to get into this stuff because shit's all fucked up. That's how you set the clock. Why would it not be able to send PWM out to one specific pin? And yet the other one, it is perfectly capable of sending PWM output to. I could probably read the statuses of these registers, something like if I had the microcontroller hooked up just right. Not sure, though. No, it's not a snafu, though, because I programmed 2 microcontrollers, and they both behave the same. Yeah. That's the part that annoys me, is that I was able, whatever I'm doing, that's why I think it's my programming procedure that's fucking it up, because that's the only difference. Yeah, situation, okay, I'm wrong about that. It is normal type of crazy error shit that kills us. I wanted to build the RC car today. I didn't want to sit here and do microcontroller shit, you know? But we left one thing undone. I'm thinking we go for the Hail Mary. I think what I need to do is set now it might have helped to set WGM, but no, you can't really do that. I don't know. I don't think you can do that. I think you can read the fuse bits, but I don't think you can read the states of the registers. I don't think you can do that unless you made something like put code into that microcontroller that specifically called out its own register statuses. I guess that would be one way to do it. Maybe you could get like an I2C display and have it print out its own register states. That's a lot of work. I'm not going to do that. See, this is the input initialization. This is the PWM initialization. I'm only setting TCCR0B. We didn't have any troubles before, unless hold on, I'm thinking about this. I mean, pin 6 is what was that one again? Hold on, I'm looking for the name of the pin. Pin 6 is PB1, so PB1 might have an enable PWM on it. Output compare match output. PB1 can serve as an... I'm not worried about that. I want to know what setting I'm doing. What the hell is all this? PC1 input and 1T. OC. Oh god, what is this stuff? Overriding signals for alternate functions in PB. Control register, pull up, disable, port B register, port B data direction, port B input address. I don't know if there's like an enable PWM that I need to do. Dead time. Timer counter 1. When the PWM mode is selected, timer counter 1 and the output compare register form a dual 8-bit free running and glitch-free PWM generator with outputs on the PB1 and PB4 pins. So we're looking at PB1, which is OC1A, right? Yeah. Wait. PB1 and PB4? PB1. PB4 is pin 3. PB1 and PB0. Oh, yeah, here. This is pins, inverted outputs on pins, blah, blah, blah. Okay, okay. As default, non-overlapping times for complementary output pairs. Dead time generator. See description page 1 billion. Okay, effect on output compare pins. Those are the compare ones. In PWM mode, writing to the output compare registers 1A and 1B, the data value is first transferred to a temporary location. The value is then latched when the timer counter reaches OCR1C. This prevents the occurrence of odd length PWM pulses. Okay, all right. During time between, right, they seem like really concerned about glitches. They're really trying to explain that to me a lot. Okay, com output, no, don't need that. Timer clock frequency, so this is what we were dealing with before. I'm looking for like an enable on this thing. See, we got the clocks all set up perfectly. Timer counter 1 control, this is timer counter 1, not timer counter 0. Timer counter compare match, modulator enabled, comparator A. We only have 2 timers in this microcontroller, so. Were we just looking at the other one? Timer counter comparator, disconnect pin, output, set the output line. I think something in here is not setting. I think it's one of these things, and I hate it. Side fumbling, yeah. Reciprocating Marsal veins. Pre-amulated amulite. Oh my god, I hate this. All right, keep scrolling. Keep scrolling. Keep doom scrolling this data sheet to try to figure out what the hell it's even trying to tell me about TCCR 0. That's TCCR 1. One's got some cool stuff going on, but we're already using it. We are concerned with not the general timing. PWM, okay, wait. This bit, pulse width modulator B, comparator, timer counter 1. See, that's not what I'm looking for. It's not what I'm looking for. T count 1. Where's all my zeros at? Are we past it? Do I need to control F? TCCR 0B. Oh my god. This is obnoxious. A sequence determined by the setting WGM bits located. See, I need anything that pertains to TCCR 0B as per its ability to output on certain pins. I've got like a big heartburn burp. Ugh. 0A bit is only active when the WGM bits specify non-PWM mode. Well, that's not what we're doing, so. 0A strobe will not generate any interrupt, nor will a clear timer in CTC mode using 0A as top. It always reads 0. Output compare B is only active when WGM bits specify non-PWM mode. It's not what's happening here. What's happening here is that some weird shit isn't happening. That's what's happening. Waveform generation mode? No. Then there's all the pre-scaling registers. You got a timer count. 0A compare register. I don't get it, guys. I don't get why this isn't working. And these get really complicated. This has to do with the machinery that basically produces that pulse width modulated signal. And I feel like it's broken. I feel like it's misconfigured. And there's not much that I can really figure out to do to get it working again. Because it really should start in a nominal state where we're able to actually use it again. I have an idea. And it's kind of a Hail Mary, and it's probably not going to work. But it'll set us on this programming path again. It's just, this is like very low level pretty powerful stuff to be messing around with in a microcontroller. And I mean, obviously, like, I've read a lot of this stuff, but, you know, reading it and internalizing it is a very tough thing to do. And it seems like chat kind of expects me to know all this stuff. I don't understand how you guys operate, but like nobody's unsure about themselves in any of this stuff when I work on it. And like, I'm just here. I don't know what I'm doing. Because like, we've got registers that depend on settings and other registers that depend on settings and other registers that depend on settings and other registers. And like, you don't need to know all this stuff in order to hit the ground running with microcontrollers. But you guys have zero accountability. That's true. You're me in some group projects. I know, right? So like, my feeling, what I feel is going on here, just to level with you guys, what I feel is going on here is that those bits that are getting set and stuff, one of them's out of whack. And I don't know the identification or the location or even what to start calling it, because these registers have enables that work on the statuses of other enables and stuff like that. Like if one mode is set here, that changes the behavior of something over here. And that interrelationship between them depends on you knowing absolutely everything about this microcontroller, and I just don't. I love the ATTINY 85. It's a tiny little microcontroller. It's very powerful. It's got enough space that you can pretty much get the level of code that I typically produce just barely to fit. And then it's got a limited number of pins, and sometimes those limitations lead you to doing all kinds of cool, clever stuff. I enjoy that. I think that's a lot of fun. But I don't know all the interrelationships between all of these register settings. I would think that there isn't much. I was hoping that I would find just like a PWM enable pin, and maybe we could manually set that and it would work. What I'm going to try to do, what I'd like to try to do, is program the bootloader, burn the bootloader, which sets the fuses, and the fuses tell your microcontroller what it is. They tell the microcontroller, well, how much do you want to scale the clock by? Where are you getting your clock from? What power settings do you have? I think those were coming from the more simple earlier Tiny 85 stuff that we programmed it with. And then I burned it probably with the core that works. That other core didn't work, and I don't know why. But what I'll try to do, I'll set the burn the bootloader from the other core and then burn it with the other core, if that makes any sense. We'll try it. And burning the bootloader is the part that sets a lot of these settings. So, oh, this has been powered on the whole time. Well, we got the big battery in it, so it's capable of that. All right, so let's get this into the ZIF socket. See, the thing is, like, I can't just, like, flip the microcontroller to... Well, I guess I could probably desolder the other one and solder it into a perforated prototyping setup. But, you know, the soldering and the resoldering isn't the hardest part of this. All right, ZIF socket. This is just like the end of the project annoyance part. That's where we are right now. I really wanted to get to just building the RC car. That's why we put so much work into perforated breadboarding the circuit, so that we knew it worked. We know the design works. That little dot. Look at this little dot. Oh, maybe I wiped it off. Opposite of pin 1, there was a little dot on the chip, and it really looked like the other pin 1. And so I was like, wait, did I put this in correctly? All right, so I need to first unlock the chip so I can program it. I just wish I had more clear indication of what registers need to be set where in this setup. Unlocked. There you go. Hell, I could even program this thing to set them. Actually, I should probably make this into more like a more universal like register and bit setter, and that way I could poke stuff into it. But right, so this thing goes in here. No, this isn't going to fix it. This is going to have the exact same result. I may need to get that other core working. So if we switch over to the other core, to the ATTINY core, nope, to the ATTINY microcontrollers, 25, 45, 85. And now this one won't load, but if I set all of my settings in here, clock, internal 8 megahertz, COM9, Tiny 85, and then I burn the bootloader. So that'll do some stuff to set some registers in here. Everybody's on the copium. We're doing it. Copium or not. Yeah, it's too much info. That's the problem. All right, so we choose the other core, the one that'll actually burn, which I don't know, something happened to the other one. Now, 25, 45, 85, no bootloader, or OptiBoot. We could probably try OptiBoot later, but for now, no bootloader. We don't need a bootloader. We're fully reflashing the whole thing every time. Eight megahertz internal. There's no other good options here. Those are all external. Tweaked, 4 megahertz internal. We need to do 8 and not 16. It will not work at 16 megahertz with the voltage levels that we're running it at. Timer 1 clock, we're resetting it, so it doesn't matter. No idea what LTO is, so we're disabling it. Millis, I'm leaving in there, but we don't need it. EEPROM doesn't matter. My dad baud level is disabled because we don't need a brownout disable because we're running off of battery. Ports COM9. Let's upload it. Let's see what happens. Boop. Actually, don't even need to upload the code because it's all the same. Oh well. We'll do it again anyway. LTO is optimization of the code. I normally just disable it because it often breaks things. Well, unfortunately, we can't blame it on whatever the hell happened with the PWM output register on this. I don't know why our PWM's messed up. You guys got to know that everything that I'm talking about here is just a theory that we can't really even prove. I mean, I guess I did prove it that it came from the programmer because we got it to do it on 2 different microcontrollers. So it's not a hardware issue, it's a software issue. But then the other microcontroller that we have that has the same exact fucking code in it doesn't work. What's that about? Or sorry, the other microcontroller, ATTINY 85, same microcontroller, but it was in the perforated prototyping board, works. Why? So, with the same exact code, I have 2 controllers that don't work in a specific way, and I have got one of the exact same controller that works. What the fuck? Okay, anyway. No, it has nothing to do with noise. A quark didn't fly through the entire Earth and then pop up against the 1 or a 0 that I needed to be set in a particular way for it to work. That didn't happen with 2 chips, you know? I got 2 chips that are doing the same thing with pin 6, which is not doing anything until they reach a full 255, which doesn't make any goddamn sense because we are definitely calling it an analog write. So what I'm thinking is happening is some register in here is getting set. We're not smart enough to unset it in our code. We're way too dumb. So what I did is I burnt the bootloader with the other core, etc. Yeah, I could solder that 1 chip in and then I'll have 1 working board total ever. So anyway, I'm trying to prove whether or not it is the programming process that's at fault. And it doesn't help that I started off with this forgetting what the process was. I had to re-remind my brain how to do thing. How brain do thing today? I don't know. Just thing do. that all matter? Thing done. Okay, so now I'm going to use hot air to solder it back in, which is not that big of a deal. It's actually quite easy to do. I just need a slightly steadier hand in order to do it. So I'm using hot air. Hot air stations are pretty cheap nowadays. I think my reluctance to show you guys like to use hot air all the time mainly revolved around the fact that it was kind of difficult to get your hands on. It was difficult to get a hot air station, but nowadays they're not that expensive. So having a hot air station is a huge level up in terms of the ease of working on things. Like this whole chip I can solder in an instant. So we'll get that ready. Hold on, I gotta belly up to the bar here. I gotta get a little closer because I'm sort of like contorting myself and holding my arms out above stuff at a height that I don't want to. Also, as I'm talking to you guys, my freaking nose is starting to rearrange my boogers. I'm gonna sneeze. Okay, so I got it set up for 500 degrees Celsius. (500°C) is a mean temperature, but if I stay back from the board a little bit and I carefully apply the heat and I keep it moving over the surface of everything, eventually this thing is going to give up and all that solder is going to become molten without doing too much mechanical damage to the board and get this thing out of here. If you don't have hot air, doing this is excruciating because you have to bend up each individual pin in order to get it to move. See that? Boop. That's boop number 1. And this is where we accidentally swapped the babies. We swapped the twins at birth. We have no idea which one's which. Heard stories of mothers having mental breakdowns because they couldn't identify which twin was which. They had all these systems in place to try to get it straight. Shred Ghoul. I think you're following. Is that soldering? I can't tell. Yeah, the solder sucker is always going to leave a little bit of residue. Ah, shit. It's going to leave a little bit of residue there, and so you won't get, you won't be able to lift the component. There you go. From its watery grave. I think I overheated that a little too much. I didn't do any damage, it's just I was kind of holding that in the same spot a little too much. Yeah, it melted all the 1s and 0s. All right, we'll let it cool off a little bit because I need to poke it with a probe. I don't want to get a burn. This is incredibly frustrating. Today was supposed to be me like actually physically building the car. I was supposed to like, boom, one, two, get over this problem and just like, oh, put in new LEDs and now everything works suddenly, right? And then we would have built an RC car and it'd be like, ha 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 ha, RC car, look at me. That would have been today. God, stupid. Electronics suck. They're the biggest mistake we've ever made. Don't get into electronics, everybody. Everything's still like piping hot. Okay, so I think we have definitely narrowed it down to it being these little bit registers that weren't, something wasn't set. So if we don't get this working today, I'll need to do a little bit of homework and figure out what my process is going to be. All right, that's cool enough that we can proceed. All right, power up. Turn the radio on. This I don't like. I got to do something about that. That initial. Nope. Fucking nothing. Nothing. That's the wrong camera. I shouldn't be on camera right now. Okay, there we go. It's the EEPROM is like getting unset, so the timings are a little different. But if we look at pin 6, this little fucker of a pin, and I go throttle, 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 and then it just goes full. Nothing, full. All right, I gotta find that register, and it requires reading. Because something is not set properly, and I desperately need to figure out what it is. It's not OptiBoot. It's not like a bootloader, because we don't need a bootloader on this thing. We're programming the whole thing with the ISP. I don't know why the other core isn't working. I don't know why this other core isn't working. Can I update it? SAM boards. Oh, this is everything. Hold on. Installed, right? Arduino contributed, certified partner. What the? Arduino at heart. Certified, contributed? No, it's not much of a board manager, is it? Boards included in this tiny 45. Yeah, I think this is the one. The David A. Mellis one. Yeah. Installation guide to install the core files. Follow this guide to find out how to build the circuit. Check out this video. Explains the setup of the core. Blah, 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 blah. 1.6 or 1.0 IDE. Okay. Well, I'm not worried about that right now. I gotta read the data sheet. I think that's... Oh, wait. Spencer Conde is the other one, right? Yeah, this is the big one. All ports supported. If a bootloader already has been loaded on the board, this must be done using ISP program. Unless you bought the board pre-boot loaded, it can be programmed via serial adapter. Nope, not in our case. Be sure the serial adapter, DTR, blah, 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 blah. Following sections, programming the ISP programmer, target, programming via ISP, VCC, ground, serial clock, etc., etc., etc. Sure you don't have anything on any of the pins that would load them down. Select your program from the tools, programmer boot menu, select version, programmer. I'm wondering if, like, there's an error somewhere in his stuff that's setting those registers badly. Like, we need to look at the definition sections for that bootloader, I guess. If this is the first time you're using a brand new chip, or if you need to change the clock source or BOD settings, you must do burn bootloader to set the fuses. If you previously used OptiBoot and wish to program it with ISP instead, or if you want to install OptiBoot on the chip, you must do burn bootloader first as well. We did that, and we said we don't want OptiBoot. If burning the bootloader, do tools burn bootloader, you should see the output of the console reporting that was successfully written. Yes, sir, indeed. We did see that. We definitely observed that. This is really frustrating. Programming via serial. I don't care. Tips and tricks. I also don't care. If you have a breakout board with holes, be sure to plug in the connector to the board. Connect the thing to the things, and then it'll work. Yeah. Arduino has ISP. It's easy to get the connection wrong. If you have a spare nano, blah, 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 blah. Okay, whatever. God damn it. God damn it. I am frustrated. Why does pin 6 not have PWM output? I didn't change goddamn anything. All I've done is program some different microcontrollers in between before I came back to this. But I've had no troubles with pin 6 previously. Everybody's saying peel up pin 6 and test it to see. Yeah, I guess I'll do that. We'll do that. Let's check the hardware. Yeah, I was wondering that too. Maybe somebody reported an issue. Issues. Tiny NeoPixel, feature suggestion, simulator, huh. Upload fails on Mac, Tiny 841, ATTINY 80C with internal 2.56. We're not doing an analog read though. Change the function of the following code, the problem solved. Add mux bits. We might run into that later. Okay, let's see. I2C buffer size, consistency, clock speed options of different supported parts, LED built-in, delays, few cycles too short, just digital write, no. Micronucleus libraries, fast digital I/O, better tiny NeoPixel, OSCAL tuning support. Current way that OSCAL tuning is done is pointless. This requires modifying variants of the board, definitely blah, 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 blah. For non-OptiBoot boards, we should have a tool submenu to support loading OSCAL from. Maybe EEPROM 0. I don't know about that. Yeah, calibration of the oscillators, I don't really care about. It's been very accurate for the stuff that I'm doing with it. Serial baud rate, getting off. Need page listing libraries, virtual boot, pinout picture, tiny 85 wire end transmission hangs. No. Add sketch for tuning the internal oscillator. Yeah, everybody wants that OSCAL. OSCAL is important because you can have variance from the factory on your calibration of your oscillator calibration. And if you've got good equipment, you can actually run an oscillator calibration, and then you can do long timings better. You do like you know, week timings, month timings, and stuff like that. I don't, you know, there's no real hint of what might be going wrong here. Ugh, man. I'm gonna peel up pin 6, and we'll see if it behaves the same way. I suspect that it will, but just to put this one to bed, just so we've got all our ducks in a row. So what I'll do is I will take the pin tool, which is hiding over here. I wanted to build an RC car today, and I end up doing this all day, you know? It's a very complicated issue. It's I really feel like, you know, the bootloader is not programming something properly, and I don't know what steps I performed with the previous one in order to get that to cooperate, but it just isn't. There's pin 6 bent up, so there's no continuity on pin 6. We can probe it with the oscilloscope, and we can see what it does. Actually, we need this view for that, huh? So I need to move this camera over to here, and we observe, once it's powered on, the behavior of pin 6. Hello? Hello? Oh, this isn't on. It's like, wait, what are you doing? Yeah, it's doing the same thing. It's definitely a register. I mean, yes, if I grab the chip from the other board, it'll work. It's not a hardware thing. We've just proved that. I don't need to grab the one from the other board. I know for a fact that it is not the hardware now, because it's not outputting a PWM on this. So flipping, you know, putting the other chip, the known good working chip in here, not useful. It's not going to do us anything. I need to look at the registers. I need to see what's set. It's too bad I can't find like the status of the registers as the Arduino wants to program them. It's not the chip itself, because it happened to 2 chips in a row. We took another chip out, we programmed it, we put it into the board, it did the exact same thing. We looked at the pin in isolation, did the exact same thing. Yeah, you guys, like, I know, everybody's throwing out suggestions. I don't mean to be mean. It's just, I've got a whole checklist of things in my mind right now. A lot of what this show teaches is troubleshooting. What factors can we systematically eliminate until we're left with only the truth? Pyro is late. How dare you? We've got... So I believe that there is a register or bit or something set that is not allowing us, not taking it personal at all. Yeah. Anybody who's been here gets your frustration. Yeah. So what we've done so far, I've fixed all the issues with the board in terms of the LEDs. So all the LEDs work. The circuit we verified. All the right stuff is plugged in the right way. So all the definitions of pins and stuff are exactly where they should be on the code and in the physical world. So we took it from the code and all those definitions that we have in software. We've looked at that. Those are correct. Those are going to the right places. We've ensured that the solder is good on the chips, although we haven't gotten to the point where we can even troubleshoot that quite so much yet. But all this stuff leads us back to something is wrong with the microcontroller. We don't get, here's the problem. When I bring it through the range of acceleration, which is basically telling the radio module to send a varied pulse width signal to the motor controller, on the output, we don't get a pulse width modulated signal on the pin that controls motor speed. This is pin 6, in the forward direction. In the reverse direction, we do get a varying pulse width modulated signal. What? I isolated the pin. The pin has that behavior. It's not an external hardware factor influencing it. The pin is a PWM pin. We are setting up the pin registers, the oscillator registers, in order to very specifically control the rate of the PWM oscillator. It works for the pin next to it. It does not work for this pin. They are the same pin. They probably have different registers that identify their behavior. One of them is supposed to be the inversion of the other in a pulse width, but that doesn't matter. We should still be seeing a pulse width on it. Well, it can be an inversion, but in this case, it's not. So the question is, like, what do we need in order to set up that PWM? And how is it being set? The only difference between these chips and the previous ones is that I forgot how I programmed them. Might be using a different core, but I burnt the bootloader on it just fine. So, I mean, one of the things that might have happened is we had different code running on our other circuits, because it was the development microcontroller. So as I was developing through the sequence of events, we could have set those registers to the proper location, and then our code now just doesn't have anything to do with it. It just doesn't touch those registers. So we've got this whole sequence of things. We've definitively narrowed it down to being something in the code that's wrong, that didn't show itself on the previous chip, but does now. Digismalls, thank you for following. Isn't that weird? We got it, just weird. It's just weird. I like whoever's updating this code. These are good comments. What's up, Digismalls? How you doing? So yeah, this is very frustrating. This is very frustrating. The question is, like, if I like burn a Digispark bootloader onto this thing, maybe that'll set all the registers properly, and then I can just come through and come back to this. But that doesn't really solve the problem, right? I mean, it does solve the problem, but it doesn't tell us why it's a problem. Like, what? I am so fucking mad right now, chat. This is supposed to be a nice, smooth stream. Everything, you know, is just, hey, flip a couple LEDs, show chat that, you know, your board isn't going to work at first. But if you're adamant about it and you make a couple small corrections to it, you can build a circuit board too, and everybody is happy. But no, this thing fucking sucks. There's something like internally wrong with our brain. I mean, our microcontroller. So we got a bad brain. And it's something that we can fix, but the fix is only going to be found by going through a dreaded microcontroller datasheet and possibly writing some stuff down as we do. It seems like it's just disabled. It seems like it's just disabled because it seems to be asserting itself as if it were a digital out. Even though it's like when it gets 255, it goes into full. That's strange. I mean, you know, maybe I'm gonna run a calibration on this one real quick. So push down, turn on the radio, push the button, connect power. Oh, you guys aren't seeing what I'm doing. Yeah, we use pin 1 as an input initially, and that's what can get this into calibration mode. There. So that's neutral. So I need to set up the controller. Oops, that's wrong. That's the burn the subs focus. Ha ha ha. Oh, burn the subs is dead. Okay, so we are in neutral right now, right? So now I hit the button again to tell it that we're in neutral. And it's going to blink the R LED, which is actually forward. Forward. That's the R and forward, okay? Press the button again. It'll register that. Program it to the EEPROM. Now we go in. Well, the F is for reverse, right? Reverse. I need to. The silk screen markings are wrong. So I push the button. Okay, and now radio off. Then it registers that timing. Good to go. Reverse, yeah. Forward, reverse. Now pin 6 isn't connected right now, so that's why we're not getting forward motion on the motor. And if I check the signal coming out of pin 6, it's going to be the cursed signal. Hold on. Nothing. No PWM. Full blast. The fuck, man? But if I look at this pin, this is what I'm talking about. If I look at this pin and I double tap for reverse, I get a PWM signal. Wow, that is a wholly different PWM signal this time. Wait a second. Yeah, look at that. That is a much faster PWM signal. Some shit went down, chat. Shit changed. After the Fire Nation fucking attacked. So, okay, something is different now. We have clock stuff going weird. Forward brakes. Wait, why is that going high during reverse? What the fuck? Wait a minute. Wait a second. You power rush. Give it a follow. It was a fun name to say. Why is that going active during reverse? Forward, reverse. PWM. Maybe pin 6 is mislabeled. What has happened here? Things are going weird. Why is that one displaying like weird digital signals? Okay, okay, stuff's a little weird today. Forward, braking. Interesting, interesting. So this should be going to the transistor that's activating, or sorry, that's PWM, yeah. So that, oh, that's right. So that one activates under braking. This one should not activate under braking, and it is. This is braking right now. If I double tap it, we go into reverse. This transistor does nothing, which is fine. That is the PWM signal, which varies depending on how much I pull this. The other end of the chip has the ones that are connected to the LEDs, which should come on initially. So under brake, well, this LED is just simply activated immediately. No, wait, the ones that PWM aren't these. These are the ones that activate the transistors. Yeah, so they're connected here. So when I go into reverse, oh, right. Yeah, the ones that are given, okay, the ones that are given PWM are the low sides. That's right. These are the low sides, and they both activate, which essentially is connecting it to ground. Okay, yeah, so that's correct. That's correct. Dr. Shenanigans. That's what we're up to right now. We're deep into shenanigans. Some shit just ain't happened correctly here. My pin 6 is not outputting PWM, and under braking, it should also be doing a PWM signal. So I'm getting nothing, and then suddenly everything all at once for the brakes, right? So that's also wrong. Okay, so my original theory, I think, stands. I think shit's fucked up, basically, is what... I I hate how Google is effectively getting everybody to stop cursing. I think that's really obnoxious of Google to be doing. They're implementing a moral standard on everyone where you lose money if you curse, and so people aren't allowed to curse anymore on the internet. It's obnoxious. It's so bad. Okay, so timer counter interrupt mask. I feel like, okay, I feel like some of these registers aren't being set correctly, and I need to figure out how to set the registers for PWM output. So I wonder if I can look up somebody else's code. Literally 1984, yeah. Do that comic where the guy's flipping the calendar. TCCR 0B Arduino PWM ATTINY 85. I curse like a goth girl? Yeah, but you're also not like publicly on the internet. Like if I were to upload videos to YouTube, they would be demonetizing me left and right for all the F-bombs that I drop. They're saying 15 years ago that people were going to try to turn the internet back into curated TV channels. Yeah, a little bit of that happens, huh? Because like we used to have a website for everything. Now we got like 4 websites. Bortech, thanks for the follow. Ba 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 ba. Default settings with coding badlies. Excellent Arduino port. 500 hertz from pin 0, 1 kilohertz from pin 1. Use this. Arduino PWM frequency how to. How do I describe this? Am I shorting against? I think I am. I think I got power going. Were you guys hearing a buzz on the mic? I was touching my desk, which is grounded, and I've got a phantom power microphone on me. You didn't hear any buzzing? Okay, because I kind of felt weird, like my leg felt weird against the table. That can happen sometimes. I'll short myself out to the table. I don't know if you guys can, you probably won't hear a buzz now. If the mic pack, the metal on the mic pack is touching my body, then it makes an audible buzz. Renewable energy innovations, okay. Compare match out mode. Tells timer 01 not to use a prescaler. PWM 1B. This enables the use of output compare unit B from the timer 1. PWM 1A. This disables the output of output compare unit A from timer. I think it has to do with these settings, and I just need to figure out what specifically I set in order to get this to enable again. Which probably means I need to test stuff, which means I need to set up the breadboard again so that I can test stuff. It's unfortunate that I'm not able to just read the status of these registers on the other microcontrollers so I know where they are. Control register A for timer count 0. You're using 2 registers A and B. 0A is 8 bits. C common blah blah blah. WGM 0 sets WGM 0 and 1. Which when combined with WGM02 from TCCR0B enables fast PWM mode. Jesus Christ, this fucking... All right. I mean, my code is sound, right? It's not my code. No, it's not me. It's the children who are wrong. I really don't want to go through all this code again. I have a feeling it's registers that are already set that aren't getting reset. I wanted to make... No, I'm going to make it first. I get to make it first. I'm the one in real time. You have a delay. Chat. I mean, you know, we do a lot of manipulation to the numbers as they roll in, but I don't think we're blanking it out. Because, like, forward and reverse are treated just about the same way. Let's look at what reverse looks like. So reverse, we're getting sent a rate. So it's being evaluated before this in order to figure out whether it's a command to go forward or reverse. And then with the number, what I do is I take the map speed, I start it at 0, just because I give it definition, and then the map speed is equal to a constraint, an Arduino function that keeps it within range. From my weenie reverse speed, which needs to be increased actually because the motor's not moving. Let me do that before I forget. So weenie rev is all the way up here. My Scooty Puff Jr. speed. So weenie rev. Now that's 0 to 255. So 165 is my weenie reverse rate. Is that actually, well, let me test that with the motor. Now that that PWM is like significantly faster coming out of this thing, I'm wondering if it'll actually get the motor to move at a slower speed. Now this doesn't account for drivetrain, but I've got it connected right now. Never mind. So yeah, with it connected, why is that glitching? That should be in the holding position. Double tap, go into reverse. The motor doesn't move. Weak sauce is what that is. That's just weak sauce. Generic, gross, weak sauce. It can't even move a motor at like 3/4 of its speed. I don't even feel any influence on the motor. Wait. Yeah, reverse will still work with that pin lifted. So yeah, we need to increase that rate. Man, it's like the amount of throttle control that you have is like nothing. It's like nothing. I'm getting a little pissed off at these fixed DC motors, these Genero DC motors. I'm thinking maybe I need to go to 3-phase, because then you can use all the energy in order to get the thing spinning at a low rate. Make that like 180. I don't get what the other what do the other controllers have that I don't? I know everybody wants to go 3-phase, but I wanted to make this work. It just seems like my own controller is not. It doesn't give me the granularity that I thought I would have. So yeah, that would be the maximum number that I can get to. So 180. I mean, I could make it like 200. I don't know what that might be too fast. But I mean, as soon as it starts spinning, it's gonna go crazy. So I don't know. Anyway, yeah, reverse is doing the exact same thing as forward, but it works. Let me go back to viable what? Viable clan member. All right, thanks for the follow. Control F. Reverse. Bob, bob, ba, bob, 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 bob. Same exact fucking thing that I did with the other one. Analog right, pin Q3, mapped speed. I'll go to forward, full forward. We just added a little line that says if the mapped speed is greater than or equal to the offset number for the maximum speed, we'll make it 255. But otherwise, we come down here and we write pin Q4 mapped speed. And that's for, oops, wait a minute. Well, same thing. Same thing with forward and reverse and braking too. Braking is supposed to have pin Q4 at that mapped speed, and then Q1 also goes active, whereas here we have Q4 and Q3 active. So that's the two low side transistor moderators. I don't know why this thing is working. Everything sucks. This is the doldrums, everybody. Welcome to the fuck zone. Probably shouldn't have said that as loudly. This is just where everything breaks down. I have one good theory about why this thing doesn't work, and I need to kind of dig around in all of this garbage in order to figure out where the problem is. From what I can understand, nothing changed between programming, so we should be okay to load that other dude's bootloader and their core. It's just something is interfering with pin 6. If I can figure out what that is, I'll be happy, because that means that I can spool new controllers constantly. I expected the fuck zone to be more fun. Yeah, so did I. So did I. So yeah, I got all the way into the calibrations here. Q3 and Q2. Q2 goes to 1, that's the high side driver. Q3 is the low side driver, that goes to the map speed. The map speed is limited to 0 to 255, and we are actually reversing it. Why are we doing that? Hold on. 255. Oh yeah, that's because the number comes in. So we've got everything exists on a number line, and so we're dealing with pulse widths and converting pulse widths into 0 to 255 signals. So we're losing a lot of resolution, but you know, it is what it is. So yeah, what the heck, man? The only difference is we've got our weenie rev right here. So rate, weenie rev, and then the offset. Whereas here we've got rate, minimum, maximum. What's the extra if in the forward? The extra if in the forward is for maximum throttle. So maximum throttle is kind of tough to get to on this controller. You can get very close to maximum throttle if you calibrate this thing wrong, but if you squeeze the controller, it will actually send a different signal. So basically what I've done is I've mapped the like top 10th of the throttle to go full max, so that you're not beating around the bush. You don't have to like squeeze your controller in order to get to it if you calibrate it a little bit more loosely. Max offset is like 240 out of 255, right? Yeah, 240 of 255. So like it's scaled based on the timing of the pulse, which we got to be very, very accurate with our using of clock registers, timer registers. But that very top of the throttle limit will get to like 250 or something like that. So what I've done is I've taken 240 to 255 and I've just set it as the maximum speed. There's not like a ton of granularity in the speed control and stuff. Not that you really need that much. I mean, back in the day, our RC cars used to use resistors in order to go slow. And so you would have a physical speed control, which was a servo connected to a lever that went back and forth and bridged contact to, oh, my stomach. It bridged contact to like 4 contacts. One was reverse. The more complicated ones had reverse. And then the others, you either had like a rheostat or you had 2 resistors, one of a large value, one of a small value, and then just a straight up connection to the motor. And it would just pull it through those. Reverse was usually done with like 2 tabs that would disconnect on the back end, and it would flip the wires around physically. We don't have that anymore, but that amount of granularity in an RC car, that's enough to get a lot done. Nowadays, you know, I'm putting in 0 to 255 in terms of like the PWM rate that's coming out of this thing and going into the motor. That's an incredibly large number of different throttle speeds. It's an incredibly small amount of throttle speeds for a car, but for an actual RC car, it's fine. I don't have to go the speed of traffic in an RC car. I'm really frustrated with this. I don't know what other stuff that I can actually like mess with. Like if I set timer 1 has nothing to do with what we're looking at. Clock source 8 megahertz. Did I put this up on GitHub? I think I did. I guess check to see if it's on GitHub, because you can, instead of asking me to scroll the locations in the software, you know, I could just show, you could just look at the GitHub. But yeah, when I define everything, it's pin mode, Q1 through 4, output. Then we set the brake LED as an input briefly. And then we do our calibration mode if it's set high. If not, we set it as an output. And then we initialize our variables. We flash to say we're ready to go. And then we initialize our timers after that. So the flashing code exists outside of the timers. But yeah. Then we initialize PWM, and we initialize our something or other. Yeah, DOS motherboard repo version 3 software. There you go. Cool. That shouldn't be too much different. I mean, I think the only differences are this. But this is absolutely where I'm going to need to alter stuff in order to get the pin working again. One pin, you know? One stupid pin. And in this case, that would be pin 6, physical pin 6, which is pin bank 1, which is on transistor Q4. Is it like totally different? Should I throw that up right now? GitHub. Let's go to my root directory, and then we can go to something else. I have a new badge. Where are we? Repositories. DOS motherboard. DOS software 3. There we go. File save. And then let's open that up in my directories. I should I should do a little bit more work to archive stuff properly. I could probably have all the different 3D design projects in here too. Should I put like links to the Fusion files in GitHub? Is that kosher? Just make a text file with that on there. I was gonna do a channel on the Discord for it, but I don't know. Maintaining these repositories is a pain in my ass. I'm not good at it. That's the problem. If I was a little bit more OCD-ish about it. Meanwhile, people with OCD are like, I fucking wash my hands until they bleed, and you're sitting here saying that you needing to organize a folder is you need OCD for that. How fucking dare you? But anyway, so I don't mean to short sell actual OCD by using that term. And we're in DOS motherboard, DOS ESC, DOS software 3, into there. Put that there. Files have been added. Commit. Processing. Yeah, this would be DOS software 3. I just uploaded it. Mr. Anderson, how are you going to sub if I have no board? I watched that the other day. All that announcement about the Matrix. I didn't watch the second two. I would like to deny their existence, but yeah, pretty excited about the new movie. How are you feeling about it? Mr. Anderson isn't in it. Or wait, no, he is. He is, sorry. But the agents aren't. You have to realize is that there is no board. All right, so I think it is one of the, I think I need to set one of the registers when I initialize the PWM mode, and I think I'm missing it. Let's see if we can find somebody else who's done something like this. If somebody else registering like a faster PWM from an ATTINY 85 on timer 0 to see what they're setting, because it seems like this shouldn't be a unique problem to me. That's why I'm looking in here, but everything got a little crazy. So let's do ATTINY 85 Arduino TCCR 0B. There we go. PWM frequency change. If I use TCR 0B is equal to that, and he just sets it immediately, and then he ORs it with that to set bit 1, it changed PWM frequency on port D0 and D1. To 0 and to 1. Oops, Control-Shift-T. To 0 and to 1, which one are those? Well, it's PB 0 and 1. Yeah, so D0 and D1. Okay. Does that mean I need to set those initial bits to 1s? Maybe I do. Do not try to burn the board. That's impossible. God, that was an irritating accent. Such a thick accent. Instead, try to realize the truth. There is no board. Keanu was like, what? What did you just say to me? I didn't understand that. Yeah, I guess I could try it. Let's see the first episode of Twilight Zone. Where is everybody? That's what the Matrix will disclose? I don't remember. I think I have. I loved when, I used to watch a lot of Twilight Zone. I don't know if I remember. Tiny 85 doesn't have the same registers. Look for TCCR1 in the datasheet. Oh, whoop-de-fuck, Fungus, you piece of crap. This kind of shit redirect I hate. This is fucked. Because they're wrong. They just brush you off with something that's wrong. Spot on Oracle impressions, like I'm back in the Matrix. Yeah, right? They sheet some of the topics, change it for you. TCR 0A, 0B. Oh, wait a minute. PB0 and PB1 around 30 kilohertz, like to drive fans, blah, blah, blah. 0A, they're setting, and then 0B. Hold on a minute. Could it be that we need to set 0A and B? I don't think that's how that works. Hold on. Should necro the thread just to reply wrong to that guy? Wrong. TCCR 0A, I think, is used for other stuff. The counting sequence is determined by the setting of the WGM 0 and 00 and timer counter control register A. What is that for? What are we talking about? That's the counter unit. I don't think timer counter control register A controls the behavior of the output compare pins 0A and 0B, respectively. If the COM 0A bits are set, the output overrides the normal port functionality of the I/O pin it's connected to. Similarly, if any of the fuck this shit. Man, these just not... What does it do? Can you tell me in like normal words? It's like the meme where the character goes, speak English, and they're like, it's like a balloon, and then everything explodes. I don't know. Like I need that. I need the Star Trek simplifying explanation. You gotta do that with the pins sometimes too. What do you mean? Sounded like a constipated Ozzy Osbourne. I'll take that as a compliment. Normal operation. 0A, 0B disconnected. Because we're not using the compare output module. That's non-PWM. We're not doing fast PWM either. Normal port operation. Normal port operation. We don't care about that. We're doing normal PWM mode, right? But we've set the clocks to be a little different. So maybe we need to set WGM 0, 1, and 2 to 0. What could it hurt? Let's try it. With WGM 0, 2-bit found TCR 0B. These bits control the counting sequence of the counter, blah, 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 maximum value. Table 11.5, this. Supported by the timer counter unit are normal, blah, 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 blah. All right. Timer counter control register A and B. So... timer control register, I thought 0B was responsible for the PWM rate. This guy's talking about setting both of them. Let's see if this person... It has 3, 2 on timer 0, 1 on timer 1. The number in the register's name tells you which timer the register belongs to. So anything with a 1 in it, TCCR1, doesn't refer to timer 0. 0A has no effect on timer 0 frequency. 0B does. So timer 0 and timer 1. Okay. Yeah, so we're only setting timer 0. Okay. Yeah, I think this sets that. You sometimes got to adjust both A and B registers for it to work. I saw something about this in the errata. Uh-oh. Yeah, it does kind of sound like we're getting a little erratic here. So we need to look at the errata. That's what that is, right? That's a bunch of sleeves that they put at the end of microcontroller data sheets. Oh, somebody's clapping back at Fungus. Good. Clapping with Fungus is probably a really bad idea, but that's just how I interpret what they're saying. It has 3. 2 on timer 0, 1 on timer 1. The number of the register tells you which of the timer registers, blah, 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 blah. TCR 0, A and B for timer 0. Oh, that was Fungus replying? All right, so Fungus has reformed their ways. I forgive Fungus, but his initial reply was so incredibly annoying and rude that it really kind of triggered me for a minute there. By the way, if you know, I can't live censor these people's names, I would very much appreciate if you guys would not take any names or anything like that out of here, out of this stream, unless I'm specifically saying to, you know, look at this person's software in a positive light. If I say anything negative about anybody, you keep that in here. I just got to say that. I don't think it's ever happened, but I just want to be sure that we're not putting people on blast for a comment they made in 2013. Yeah, and if anybody had any confusion about whether or not they should do stuff like that, please just never participate in the internet. Yeah, Fungus enters the stream. I think we have a cream for that. But I think all the idiots are taking it to fight COVID or something. Like I say, necro the thread and say wrong. No. 0A and 0B, timer 0. First PWM port, PB0, and TCCR1 for timer 1. Second PWM port, PB1. Wait a minute. TCCR 0A and 0B. TCCR1 for second PWM port. They should both be used. I think this is a little confused. Well, I mean, we're reading forum posts, and forum posts, unfortunately, can be pretty inaccurate, and this is some pretty weird low-level stuff. Timer 0 has 2 outputs, but only 1 counter. You can change the pulse width independently, but both will have the same frequency. Ah, yeah, see, Fungus knows what's up. They know what's up. Timer 0 counts at the speed of the CPU clock, and then the dividers and stuff that we already figured out. Remember, though, that each PWM pulse will be 256 clock ticks long because it's an 8-bit timer. The output goes high when the counter is at 0, and low when it matches the number of the compare register. OCR0A for the output on PBO, OCR0B for the output on PB1. We have problems with that image loading. We have problems with PB0. PB1, no, we have problems with PB1. PB0 works. PB0 works. PB0 works. So, where are they saying this? This is a slightly better explanation than the data sheet, so. So OCR0B, OCR0B is what we're having troubles with. Control F, OCR0B. Output compare B. 0A and 0B. Rate. WGM2 and WGM1. Those should be set as normal, right? WGM 0, 1, and 2 should all be set to zeros. And then the OCR whatever updates immediately. Modes of operation. Behavior of the timer counter. This thing is a choose your... Okay, so one thing you guys should know about the ATTINY 85 datasheet is that it is a choose your own adventure novel. It just said, you know, to get information about this, go to this section. So I did, and then it almost immediately says, hey, you should go to this section, actually. It is a choose your own adventure datasheet. I hate it. So now we're here. I remember having to do PWM in a school exam in the Arduino AVR code. I had an hour for it and a whole bunch of other stuff. Listen here, you whippersnapper. Back in my day, back in my day, I'm not old, but according to the internet, I should be on life support. Back in my day, we had to put code through a microcontroller on pen and paper, and we had to write down how the registers were read, manipulated, and then put back into memory in order to make it perform an instruction. Ow! No. All right. Put the salt gun away. It was horrible. It was horrible. It was the worst thing. That was the same one where we had to take a robot and have it go through a maze, and it would have to bump stuff initially and then figure out the direction of the maze. We'd press a button on it, and then it would go through the maze. And so I tried to do code where it uses Pythagoras' theorem in order to cut corners and go faster through the maze. And it didn't work at all, and I didn't have time. So I literally just programmed the sequence of timings in a big block, and I put a note above it like, hey, this is how I did it, just because things didn't work. And I got like an A on the project because they thought it worked, but it was all there for them to look at. The TA just didn't read any of the stuff. They didn't read my code. They just gave me a good grade on it. God, that was an annoying one. Nothing like opening 8 copies of a datasheet to get one piece of information. I know, right? Luckily, I'm not. Maybe I should be opening different copies in order to do this. That's actually a good idea. Compare match output. This is what we're talking about. 2 functions. The waveform generator uses it. We're not using the waveform generator. Next compare match. I think we're doing a next compare match, maybe. The examiners never read your paper and only look at your presentation. Yeah. It was, I mean, there was a test attached to it, but I guess they only just saw my robot do diagonals. Which, to be fair, nowadays I could do that. I could sit here and write a robot that would figure out where how long it should go until it hits a wall, etc., and then have it calculate like an optimized path. They'd probably use some pretty advanced math to do an optimized path on it. We use Bezier curves and shit like that. But back in the day, like, man, I barely even knew what typing was for variables. So that was a tough one. And here we are looking at clock registers. I hate this. I hate having to spelunk into a data sheet. COM0X bits control the OCX pin output source. Shows a simplified schematic logic. Ba-ba-da-ba-ba-da-ba-da-ba. I/O register bits, the I/O pins in the figure shown in bold. Only the parts of the general I/O port control register, and port that are affected by COM, blah, 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 blah. If the system reset occurs, the OCX register is reset to 0. Now, so maybe that's not the issue. I think it's the W something or other thingy that we were looking at before. If we go back to TCCR0B, which I think has been the suspect all along, the WGM WGM ports, the Chief Wiggum ports, 0, 1, and 2, maybe they have an influence on the control. That doesn't tell me why one works and the other one doesn't, though. Why does one PWM work and the other one doesn't? What am I doing differently with reverse than I am with forward? Why is this... this is so frustrating, guys. This is like the pits. Dr. Matthew Damon, thank you for following. The answer is always one bit not set right, or a bit that needs setting in a completely unrelated register. Yeah, welcome to microcontrollers, right? Welcome to microcontrollers. Because, like, consonant pins, so those are set there. We got the radio pin, and then the brake LED is our only indicator, because that's not connected to anything else in the schematic, right? We have a very limited number of pins. We're making the most out of all of them. We come down here, and this is where I initialize everything, right? So the initial flashing of the microcontroller LED and all that stuff, all the initialization of all the variables and stuff like that, we're fine with that. The checking and loading in the EEPROM is, I actually like that piece of code. That's a nice piece of code that I made all the way down to the bottom of this program. However, we initialize PWM, and we are only setting TCCR0B. So... but the problem, why does register A and B behave differently? When we initialize these pins in the main code, in the setup of the code, we're setting them all as outputs, and that's all we need to do, right? None of these are analog inputs or anything like that. We set them as outputs. They should be able to do analog write. So what happened? What happened? That's our calibration mode sequence. Break LED is then set to output. We initialize all of our variables from the EEPROM, which means basically like it's a version number kind of thing. If the version number matches, then it will load the numbers from the EEPROM so it doesn't get junk data. And then we can go in and we can actually program those memory locations. Initialize PWM, and then initialize the input 0, which we're setting as an interrupt. So every time there's an interrupt from that pin, we time out, and we have overrun timers as well. But we have a time measuring system based on the status of that pin. So it's a direct control kind of thing. That's how we get very consistent numbers from a foreign pulse that we don't really know what it's doing. We have parameters that it can fit within in order to control our system. So this is TCCR1. We're stopping the timer. We're zeroing the count. And this is more stuff with TCCR1. I'm just looking to see if I do anything weird down here, right? ISR int0 vector. That's the slow and the fast timer counter. And these are all timer 1s. We're not doing anything with that, right? There's two sections here. One of them involves timer 1, and the other one's just PWM set for timer 0. The PWM pin is for driving forward, and the other one is for reversing. No. The PWM input pin comes from the RC. Oh, good night, Mystery 836. Thank you for the help, man. I appreciate that. You know a little bit about this stuff. Okay, so what's happening is we're getting a servo signal. And so the servo signal tells the servo whether it goes clockwise or anti-clockwise. I think it's like 180 degrees. And there's like a timing parameter for that. That's all documented. That's all like stuff that we can look up on the internet and we can factor in directly. So it either goes positive 180 or negative 180 with a certain number of steps. But we need to turn that into 0 to 255 signals that go to an H-bridge controller. And so that H-bridge controller is responsible for activating 2 transistors or the opposite 2 transistors. And the ones that are on the positive voltage side click on and off, whereas the one on the negative side will get a pulse. So we have 2 pins, thank you Flatulent Gonad, we have 2 pins that are gonna output pulses. In order to control a motor and not have it be all stupid, we need a fast PWM signal to go out to that motor. So in order to have a fast PWM signal on an ATTINY 85, timer 0 is going to be needed in order to speed up that automatic PWM generation. In addition to timer 0, we need the second timer. It only has 2. In order to output that second timer, we need to actually, or in order to utilize that second timer, we need to set it up. And what you do is you set up the register every single time you use the timer. So you set it up and it's got an overrun and stuff like that. So we can zero it out and stop it and we can start it again. And so that's how I'm measuring the up pulse and the down pulse, the up dog and the underdog. That's how I'm measuring those pulses. And because that's done in clock cycle timing, it's very accurate for what we get back. Otherwise, if we use regular Arduino like analog input or digital in, if we digital read those pins, it actually puts extra delays on things, and we're talking about microsecond timing. So that's the way that this code works. That's my manic rant about how the code is supposed to work. I don't know, what's up with you, Uncle Phil? Uncle Phil just said, what's up, dog? I don't know why he would say something like that. Okay, so ISR int0 vector triggers the blah, 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 blah. So anyway, that's what all that stuff is, right? PWM setter, evaluation pulse PWM. If the calibration flag, evaluate something pulse time. Yeah, none of this. This is for setting the EEPROM. So up here is the only place that I touch this thing's jiggly bits. Maybe if we just set WGM. Jim, hey, thank you for following. Jim from the UAE. PWM, yeah, let's set the WGM. I mean, I basically need to set them all to 0, so we're in normal PWM mode. I could try to use fast PWM, but I don't really know what that is. I don't know if we should mess with that. OCRA is oscillation control register. We're having trouble. Okay, so here's the, and then just to throw a wrench in the works, the problems that we're having with the PWM output affect one pin. They only affect one pin. One of them. The other one works fine. Why? No, we've been through that. Yeah, Mr. Anderson, I know. Arduino core library uses timer 0 for some internal stuff. Now, we got this working. Today is a prime example of why I'm going into mechanical engineering. Amen. And the mechanical engineers were cooler, but this stuff is in my blood. This kind of problem that's really frustrating that you can really kind of sink your teeth into, and you can go galaxy brain in order to fix. I kind of like this. I kind of like this. As frustrating as it is to not be able to assemble an RC car today, I am glad that we found a weird problem, because microcontrollers have weird problems sometimes. Weird problems that require you to really get your fingers into places that you didn't want them. So my issue here is that we're having trouble with one of them and not the other. If we can figure out, and I think that's the last piece of the puzzle. I think that's the last piece of the puzzle, and how we're going to find the answer is that this thing has this specific problem. Everything else seems to work. If we can answer the question, why doesn't pin 6 output PWM, but pin 5 does? If we can answer that question, I think that's going to solve our issue. I think that's what we've pinned it to. We've sort of eliminated all of the whole spectrum of shit being fucked up in various weird, unique ways. We've laser focused it down into this one thing. That's troubleshooting. You need to have kind of, I'm not going to say I'm good at it, but it's kind of like a natural process when you've worked with stuff enough that you know sort of how to isolate your problem and get all the stuff around it. Writing stuff down helps a lot for stuff like this, just so you know what factors you've ruled out. But if I can answer that question, I'll be pretty happy. So I think, yeah, we're at closing time, and I can't figure out what the fuck this problem is. I think, and that was me stalling just now. But those are your takeaway lessons from today: is become a mechanical engineer. Yeah, basically just figuring out how to isolate the problem into a singular question that needs answering. And if that doesn't work out, I don't know what to do then. Because I need to solve this, because it is not good practice to be a programmer in this case. It's not good practice to be a programmer. I need to be an engineer. A programmer would go, I don't know why this works, but that's what we're gonna do because it works, but I don't know why. That's not being an engineer. That's not, I need to know why it doesn't work, and I need to fix it because it's a problem. Back to school shirt lurker, because sorry man, everybody needs to become mechanical engineers now. That's how the world works. Hey, everybody could learn a little mechanical engineering. Man, this sucks. I was hoping I'd have little RC cars by the end of the day, and we could shovel all the stuff into the background. I'm gonna do some research on this on my own. I'll have to read up about the timer registers and figure out if I need to like set one of them or not. I'll put up a little breadboard test so that I can just poke at stuff to see what works. And hopefully I can solve this problem quickly. I'd like to know why it's failing though, because this is a big deal. Like one of my PWMs just doesn't PWM. Why? Why? I put all this time and effort into this thing. I hate to end on a low note like that, but it's just yeah, it's just what we got, man. Okay, Deathloop is just about the most boring AAA game I've ever seen in my entire life. It is shooter number 5 with 4 tweaks to it from other AAA shooter number 4 that had 3 tweaks to it. It's like, I don't know. I really want to rate Djibouti show, but I'm not, because it's Deathloop. Sorry. Final Fantasy Online, I don't enjoy watching. And I enjoy watching Project Zomboid even less. So I think we're going to shutter the stream. Davies is actually not streaming while I am? Okay. Wait, is he? Hold on, I gotta... He's just not showing up on my bar. Sorry, unless you got a time machine, that content is unavailable. He died! He's dead! I'm spelling it wrong. Well, either way, you guys can go to Davies if he's on. He had work today? Ah, gotcha. All right, so we're just going to mothball the stream. We're going to pack it up. We'll unpack it tomorrow. I'm not going to work on RC cars tomorrow. We're not going to go datasheet spelunking tomorrow. Yeah, you guys will exist in the void until I start up again. Basically, when I'm not streaming, I sit in this chair with a blank expression on my face. That's essentially how it goes. And then I've got a timer, and then all the lights turn back on, and then I just start talking to the wall again. It's good content, and it pretty much auto-generates itself. Anyway, yeah, tomorrow we're going to do something else. It's Friday. I would like to take something apart, but I don't know if I have something to take apart. We could do the CPAP machine. I got my old CPAP machine, and that's kind of like... Yeah, we can take a look at that. That'll be some cool motor stuff. It's also covered in disgusting dust and like bacteria and shit. So that'll be kind of fun to do. Yeah, we'll do CPAP tomorrow. We'll take apart a CPAP machine tomorrow. Over the weekend, I'm going to buy wood because that's just what I do. And I would like to come up with a couple cool things. Excuse me. We'll come up with some cool little pieces of software that we can use in order to spool up the next board and get that running and functioning. Till then, I'm O'Bother. I'll see you tomorrow. Why are you